Yeah. So yeah, coming back to the point. So we've discussed all of these things. We talked about collection framework. We talked about the entire hierarchy of the collection framework. No, I'm not on mute. Uh, am I not audible? I am audible, right? Yeah, yeah. Okay, yeah, sure. Thanks. Right. So we also talked about collection framework, and then we talked about yeah. Thanks for confirming, Manishan, and thank you. So we talked about the collection framework. We talked about the entire hierarchy. We talked about array list and stuff. So if you remember, if you recollect, can any one of you tell me which class implements collection interface directly? Is there any class that implements collection interface? Please recollect the hierarchy. And I did share yesterday all the drawings that we have done, my whiteboard that I used, and I did share. I hope you all got a chance to go through it. So if you can tell me which class implements collection, is there a class that implements a collection interface? Is there a class that implements collection interface? Any idea? Right, so no, there is no class that implements collection interface if you recollect. Okay, now let me share my screen. Can you see my screen, friends? Okay, yeah. Well, you don't need to confirm to me because now WebEx is state of the art. I can see it very well tells me that I'm sharing my screen. So that's cool. Okay, so you see this? Take a look at this. Take a look at this. We did this yesterday, isn't it? Correct? We did this yesterday. So you see, there is not even a single, a class that implements collection directly. There is not even a single class that implements collection. Collection is the supermost abstraction. That's how you will put it in a statement. Collection is a supermost abstraction. So you've got list, you've got set. These are the two abstractions again, which inherits from collection. These are the two interfaces which inherits from collection. And these are the classes, these are the classes that implements respective interfaces. For example, list and array list, they implement list and then has certain stuff. So we discussed all of these things. We did, try our hands on this. Well, we did not write any code for this, but then yes, you have a tree set. You can always create a tree set. You can say sorted set is equal to new tree set, and then you can keep on adding values to it. It will be ordered in the natural, ordering. As per the natural ordering, it will order it, right? That's how it is. So the tree set works like this. So this is what we have discussed, and then we talked about collections. I mean, sorry, the exceptions as well. Towards the end of our day yesterday, we talked about the entire exception handling. We talked about the fact that throwable is the supermost class in the hierarchy of throwables. So this is the name of the class, throwable. What is the difference between exception, I mean, this exception and the error? Error or fatal errors usually used by, we don't use it as much as we do exceptions in our business applications, but errors are the ones that are used by Java a lot. Like, for example, out of memory error. And then you have an exception class inherits from throwable. Yeah, there is a chat. Now see, this is the beauty of WebEx. I get notified when there is a message on the chat window. I can't hear anything from Sir. I can hear Nikhil. I don't understand what the issue is. Try reconnecting. Okay. Okay. So in the meanwhile, let's continue, friends. So you see, we have got exception, but that exception itself has got its own hierarchy. You may have n number of exception classes inherited from exception. You can have runtime exception inherited from exception. What is the difference between the two? These are checked exceptions. This hierarchy, checked exceptions. Whereas runtime and everything within the hierarchy of runtime. What does that mean? Any class that belongs to the hierarchy of runtime. Maybe I have got some class that inherits from some other class that inherits from a runtime exception. Everything in that hierarchy will be unchecked exception. What do you mean by unchecked exception? It can go unchecked. That means it can go without the try catch block. Compile time, compile time, compile time. Runtime, of course, if that exception really occurs, it occurs, and you have to. Okay, I'm the host of the training now. Thank you. right? So you can, that's how it is. So my runtime exception or any other exception that is inherited from unchecked exception, they are all unchecked, right? That's what we discussed. Very importantly, then we moved on to streams, right? We moved on to streams in Java, isn't it? Isn't it, friends? That's what we did. We moved on to streams, and you recollect that stream is what? Stream is a wrapper over what? Collection. And it is an iterator. Internal iterator is available with stream. This is an important point, right? Stream has got an iterator internally, which iterates over each one of those elements. Please do not be under the impression that stream contains the data that is there in the collection. Please do not be under the impression that the data that is there in the collection is copied into the stream. Some kind of a container, some kind of, stream is not a container. So please do not be under the impression that the data is copied within in the stream and then some processing happens. No, it is an iterator that iterates over the collection, whichever collection you have specified as the source of the stream. Note my words, source of the stream, correct? So you have stream, and then what is it that you can do with stream? But even before streams, we discussed a lot about functional programming. Come on, friends, that's the crux of the matter. Let me tell you this, friends, if you do not know functional programming today, I mean, you do not have a choice. You cannot get away, you know, without understanding functional programming. You just cannot move an inch unless you decide to use Java 1.8 or Java 11 or Java 15, 16, whatever. Unless you decide to use it as same as you were using Java 1.4 or 1.5 or 1.6 or 1.7 for that matter, then that's your choice. But if you really want to, use Java, right from Java 1.8 onwards, 16 is the latest. So if you want to use this Java, today's Java, then I mean it's difficult that you move an inch without understanding functional programming, right? And every framework, every library that is currently the latest versions that are available out there, right? In Java space, they are all rebuilt and they are already, and it's not a new thing. I mean, it has already happened, and they are all redesigned, rebuilt on the principles of functional programming. So, what is a functional interface in Java, especially? Right? You may have different constructs of creating functional interface in other programming languages like Scala or something else. But then otherwise, in Java, an interface that has got one single function declared in it, one single function declared in it is a functional interface. It represents a functionality. It represents a particular functionality. That one abstract function. Okay, now this is important. A functional interface can have many functions, but one abstract function, rest of the functions can be static or default functions. I repeat, rest of the functions in a functional interface can very well be static or default, but one function will certainly be what? An abstract function. If you have more than one functions, if you have more than one functions as abstract functions in a given interface, it is no longer a functional interface, which is okay. There are still hundreds and hundreds and hundreds of interfaces still in Java library that are not supposed to be. They are not as per the design. They are not intended to be functional interfaces. Fine. They define the contract, they define services. There are some classes implementing all of those services. The best example is list. List is not a functional interface. You have array list and linked list implementing list, correct? That's how it is. Okay, there is a question. Sir, can a functional interface have a private function? Hush, I never tried doing it. But if you have one, how will that be of use to you? If it's a default, you will not be able to use it, in any class, and you will not be able to access it. If it's a static function which is private, again, you will not be able to access it. If it is an abstract function, how will you? No. Abstract function in an interface, forget about functional interfaces. Anyways, they cannot be private. Even if you do not specify private or public, they are definitely public. An abstract function in an interface is anyways public, right? So one message I have. Can we speak? Oh, yes, Nagaraj. Yeah, tell me. Nagraj, please go ahead. Right. So we did talk about streams. So that was important. And was there a question on streams or functional programming? I think there was a question. Private function. So no, you cannot have a private function. Maybe programmatically you can try it out whether it gives you a compilation error or not, but it will be of no use, and never do that, right? I mean, I don't see any use case for it. Okay, so coming, proceeding further, we talked about streams, and very importantly, we talked about functional interfaces. When we talked about, come on now, all of y'all must answer this. What is the function that takes another functional interface as a parameter known as? The function that superb, very good, Anand. Nice. No, no, Pooja. No, no. Yes, it's known as higher order function. It's known as higher order function. And tell me, filter, map, these are what kind of functions in stream? Stream has got a function, right? So what is the stream known as? I mean, sorry. The filter and the map known as. Yes, filter and maps are higher order functions. So what it takes as a parameter is a functional interface. Like, for example, filter takes a predicate. Map takes a function, java.util.function.function. And then filter takes java.util.function.predicate. And there are many such, there is a flat map, which again takes java.util.function.function. There are many things on the stream interface. Right, friends? That's how it is. Correct? You're getting the point. So this is what we discussed, and then we did try our hands on. I mean, you all did write code for, filter for map, and then using filter and map together in processing some collection. We have done that as well, and then we have written some code in order to get the minimum value, from a given collection using streams. So all of this is what we did yesterday, and as I said, we have done exception handling and all. So friends, understand this. So what do you think? How would you rate yourself on Java today? After these 3 days, today is the fourth day we are starting. How do you? I mean, what is your confidence level, and what is your comfort level with Java, and what is your? I mean, what is the kind of love that you have for Java today on the scale of 1 to 5? What is the kind of love that you have for Java? 5 being tremendously in love with Java, 1 being not interested in Java. Good, super. I'm happy with these answers. Oh, Monisha, that's nice. 3.8 is so very precise. That's nice. Okay, so those who are saying 3 and those who are saying 4, I'm sure you will fall in love 5 out of 5 after I show you this. Okay, I'm going to show you something now. See this. Can you see my screen? Okay. See, this is the guy who is a Java champion. He's a Java champion. There are very few Java champions in the world. Very few. They are in hundreds, not even thousands. They are hundreds all over the globe. Hundreds. Okay, they are very few. It's not a, Oracle certified JCP or Oracle certified architect or kind of a program. A consortium of Java champions, uh, uh, you know, accept someone else as a Java champion. I mean, they certify existing Java champions. They certify, oh, okay, you are also a Java champion when you have contributed to the community, when you have built frameworks, APIs, you have trained people, and so this guy does trainings. This guy does trainings. Okay, one of his training programs, for example, let's pick up, Java concurrency. Okay. Okay, now he's doing everything online, but then otherwise, you see this, I'm going to show you Java training. Okay, this is, you can see this here, extreme Java, Java advanced topic. You can see this. Okay, See the amount of money that he charges, my dear friends. This is per participant. Okay, he is now, not okay. Here it is. Here it is. Price is 6,500 up for 10 students. Euros. It's euros. 6,500 euros for a 4-day training program, right? And 650 per student about that. What does that make? Right? What does that make? 6,500 into, and this was earlier on the higher side, but maybe as it reduced as 6,50,000 rupees for 4 days of training program. Trust me, this was very different. I think this is, yeah, this is for 4 days. But otherwise, earlier it was 17,000 USD. It was around 13,000 euros earlier, around 9.5 lakhs. So this is what it is. Now tell me how much of love you have for Java. 5 out of 5. Okay, still 4. Still 4. You will have to wait for 2-3 months in order to get a seat in his training program. Yes, that's better, Rakesh. 6 lakhs in INR. 6 lakhs in INR. Yes, 6 lakhs in INR for 4 days of training program. Correct. 4.3. That's better, Anand. Well, what I'm only trying to tell you is Java is huge. It's extremely interesting. It's brilliant. It's marvelous. You can do wonders. Out of 10, 8 frameworks in the open source community are all on Java. All your server side technology is on Java, Java rules. And if you think that what we are learning is the only thing in Java, this is just a drop in an ocean, but the building block. If you are expert in the fundamentals of Java, you will be able to build in time to come, my dear friends. You will be seeing yourself building your own libraries, building your own frameworks, and building your own products for your organization, right? You can do wonders, right? So this is what it is. Come on, now let's get started. So there are quite a few things that we are supposed to, cover, and we are supposed to talk about as we proceed further. So I have some few topics over here, and this is fast track. I repeat, this is fast track. You are supposed to make note of these things that I'm talking about. You are supposed to make note of it, not necessarily make note of in the, with a pen and a paper, because if you try to do that, this will not be a fast track. Then it will result into, like, I mean, we will need 3 more days for all of these things. Because if you keep on writing, I need to repeat and it will take time for you to write. So when I say make note of it, make note of it over here. You must know that, okay, these are the things that exist. You must know that these are the additional points over and above that we have already talked about in these 3 days, in last 3 days. I repeat, making a note of it is like this fast track is like you must be aware, you must make yourself aware that these are the additional things that you will come across, and this is the concept behind it. That's it. Over and above that, whatever we have discussed in last 3 days. So I will get started. Right. So see here, the first thing we have talked about object-oriented programming. We know what are classes, constructors, and inheritance, right? So that's not a big deal. You know what is a constructor? Constructor helps you to create an instance of a class. And can there be more than one constructors? Yes, you can have multiple constructors, overloaded constructors. When you say overloaded constructor, one constructor, with one parameter, another constructor with two parameters, one constructor with no parameters at all, the default constructor, and so on. You can have multiple constructors. Now about overloading, my dear friends, I get so excited, and I want to, I love to share knowledge. I love to share, and I had told myself just proceed further, Shakir, one after this, but I just can't. I'm so sorry about it. I just can't. I would like to talk more about overloading. I have seen people with 10 years of experience. They are not clear. They know the definition. They know the bookish definition of overloading. I would like to talk about it. So whether it is overloading of a constructor or it is overloading of any other function, understand one important point here. I'll put it in basics. Really, thanks to PwC that they have given WebEx to us. That's marvelous. Okay, so see this, friends. Now I can see myself, and I can see that the window is being shared. My machine the screen is being shared, and everything I can see everything here. So it's brilliant. Okay, Now see this. So I have a function here. Suppose I have a function here. I say public void. I'll say print names. Suppose, okay, and print names is supposed to print, or I'll say print employee details. I'll say print employee details. Suppose this is the name of the function, print employee details, and I write some logic here. And that logic, entails printing the name and then the surname, and then it also prints address, right? That's it. These are the things it prints. But then now you have a requirement. You have a requirement that based on the condition or based on what the client class needs, not my words, what the client class needs, you may want to print some additional information. And that additional information is, for example, department details. But sometimes you would want to invoke this function such that it prints only name, surname, and address. And sometimes you would want to invoke this function. You want to invoke this service. See, many a times you might have seen me calling it as a service. And sometimes you want to invoke this service in such a way that it, along with the name, surname, and address, it also prints the details of its department, the name of the department, the head of the department, and so on. Department details as well. But that is, sometimes only this, sometimes along with the department details. So you decide. What do you decide now? You decide to write another function. Because the service is the same, you say print employee details. And you say Boolean. What do you do? You say Boolean. You say print department details. Right? This is a Boolean value. So what you do now is that whenever you want to make a call to this function, so let me create an object of this class, demo is equal to, I'll write overloading demo is equal to new overloading demo. And here I'll say overloading demo dot. You see, I have two functions here, but the service is one. Note my words. I'm saying the functions are two, but the service is one. What is that service? The service that is being provided by this class is to print employee details. That's the service. And in both the cases, the name is exactly the same. So the service is same. I may either call this service in order to print just the name, name first name, last name, and the address, or else in some cases, sometimes I may want to, from some other place in my application, I may instantiate this class. Note each and every word of mine. I may instantiate this class. I mean, what does that mean? I will create an object of this class and I will say true out here. What does this mean? I want to print not just simply the name, address, and because the service is the same, right? But some additional behavior, One more time, some additional behavior. I want to print the department details as well. So print department details true or false. I say true. Correct? So far, so good. This is what overloading is. Now, how do you implement these two functions? So you have written some logic here. You will write that logic here again, but that additional logic will also be written over here, right? That additional logic will also be written over here. What is that logic? Logic of printing the department details. All with me, friends? We are not yet done. There is a final punch coming in this discussion. So far, so good. Any questions, any doubts? So, are you good with this? I am writing the logic of printing, okay? Logic of printing name, surname, and address here. And I will have to write, of course, the logic of printing name, surname, and address here, and then additional logic of printing that. Is this good? Is this just perfect? Is this just perfect? Yes or no? Or do you see a problem here? Do you see a problem? Come on, guys. Each one of y'all must be the Arya Bhatts of your organization. Come on. You must be the Arya Bhatts of programming world of our country. Why? What is the problem? If you say this all is not good over here, what is the problem? Can I get someone to tell me what exactly the problem here is? Yes, Anikendu, tell me what is your doubt. Yes, Anand, brilliant. How is the same function being used for two different services? No, the statement is not really, I mean, not one function being used. It's all about concept. It's all about concept. Programmatically, how many functions? Two. Conceptually, I call it one service. Why? Because conceptually, I am here also, I am printing the employee details. Here also, I'm printing the employee details. Service that I'm providing is the same. It's just that with additional behavior, I will print the additional function, additional thing, that is the department details, right? Very simple. Come on, plain simple English. Two functions, but the service is one because conceptually I'm saying the service is one. Here also I'm printing employee details. Here also I'm printing employee details. It's the same service. Come on, with some additional behavior. Okay, so coming back to the point here, what is the problem? Gaurav says redundancy. Brilliant. Then Anand says duplication. Yes, absolutely, absolutely. There is duplication here. No, overloading is fine. This is overloading, yes. So that's what come out of books, yeah. Come out of books. Books are good in colleges and you study, they're good. But now you've got to get into the things and I'm happy if you give me an answer. This is overloading. But there is a problem here the way I have written the code. What is the problem? I have repeated the logic of printing name, surname, and address here. Come on, yes or no? I have repeated the logic. Yes or no? Good or bad? If I am duplicating the code, is good or bad? It's bad. It's bad. Tomorrow, if there is a change in how you print, note my words, friends, don't miss this. Tomorrow, if there is a change, do not ever think that you write your application today, which will never be changed tomorrow. I repeat, never ever think that the code that you're writing today will never be changed tomorrow. It will change for sure. If it is not changing tomorrow, that means they have stopped using your code, right? They have stopped. They have thrown away your software. If they're using it, definitely they will ask for a change. The business environment changes, the competition changes, the business demand changes, business rules change. They may come back and ask you. So if at all the logic of printing name and surname changes, how many places will I have to make change? Come on, how many places? Two places. Bad. Bad. So what will I do? See now, crux of the matter, crux of overloading, crux of the matter. Understand this. So what I'm going to do, I'm going to write all my logic in the function that takes additional parameter. Note my words. I will write all my logic in the function that takes additional parameter. And from here, I will remove this. I will say print employee details false. I will pass the default value, and here this will be executed if print employee details. If that is true, only then see this. Now this is just super. This is perfect. Now, if tomorrow the logic of printing the department details changes, you're going to make change here. If there is a change in the logic of how to print name, surname, and address, you make changes here. You don't make changes in both the places. But for the client class, these are two different functions for the same service, and I can call that service in whichever way I want. I can call the service without passing a parameter. I can call the service while passing a parameter. I know very well that this will give me what? Only and only the first name, the last name, and the address. Whereas if I say additional true print department details also, it's the same service. That means same service. That means it will certainly do what this is doing, but additionally, it will print the department details as well. I hope the point is conveyed across. You all are all intelligent enough to understand such simple and easy thing. Come on, say yes. Say yes. Okay, good, 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 brilliant. So always remember this. I'll give you an example. Come on, I'll give you an example. Class loader. You remember class loader? We talked about class loader on second day, if I'm not mistaken. Class loader. What is the name of the function that loads the class? What is the name of the function that loads the class fast? What is the name of the function that loads the class? Come on, I'm giving you the hint. What is the name of the function that loads the class? Hey, that is the name of the class here. Come on. Hey, hello. Class names are. I'm saying the name of the function that loads the class. Function names always start with a verb. Where are you guys? Class loader is the name of the class. Come on, this is the class. I'm asking. The name of the function that loads the class. No, 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 no. That was programmatically here in the class loader component. Okay, no problem. Maybe you missed it. Load class is the name of the function. You remember this? See, load class is the name of the function. You see this? And you remember I did show this to you. Say yes, I did show this to you. Yes, correct. So load class is the name of the function. You see, it takes two parameters. This is the parameter which is additional. This is the parameter of the name of the class that needs to be loaded. And you see the entire logic is written over here. You can see this. The entire logic is written here. Whereas there is another load class method which just takes only one parameter, overloading. Load class, this takes one parameter. Load class, the same function again written, but a different set of with a different signature, an additional parameter. See this, did they write the logic in two places, or they have written the logic in the one that takes additional parameter, and they have called that function which takes additional parameter from here, passing the default value false. I hope the point is conveyed across. Come on. I'm sorry for my bad throat today. And you see this towards the end of that function load class. What is written? If resolve. What is that resolve? The second parameter here. If resolve, then resolve class. Otherwise, don't resolve the class. Only do what it is supposed to do. Right? You got it? Come on, come on, come on. We'll proceed further now. So you know what are classes, So similarly, constructors can be overloaded. Constructors can very well be overloaded. What was the name of the class in which we created constructor? Okay, fine. So you see this, if I have a constructor here, I say const public constructor. I can have an overloaded constructor here. Correct? I can have an overloaded constructor with say int id, and I may write some logic over here. Whatever logic I want to write, I will be writing it over here, and from here I can make a call to this dot, or I'm sorry. Okay, I can just simply call customer with the default value, correct? Or else I will return, I'm sorry, this. You can see this here, right? I can call this constructor here like this. So I can make use, I can write all my logic over here, but from here I can call this another constructor. This is how I will call the constructor in the same class. Reuse the value. I mean, it's just that not that I'm calling this constructor will be certainly executed, but then I'm calling this, right? This is how it is. So overloading of constructors. Classes, constructors, inheritance, inner and abstract classes and interfaces. We have talked about interfaces. We have talked about inner classes. What is an inner class? Very simple stuff, friends. So an inner class is a class like this. Okay, I can have a class within a class. I can have a class within a class. So if I write a class over here, which is say, for example, my tax calculator, something like that, for calculator, then in that case, this is my, sorry, this is my inner class. This is my inner class. I can very well write a class within a class, and I can refer to it through the instance of this class. Why? Because this is not static. Whereas, so as I said, this is going to be fast track now. Okay, this is going to be fast track. Now I say static. So just make note. What is it that you're supposed to? Are you going to understand the entire science behind inner class? No, this is a fast track, rapid fire kind of. But you must know that there is something like this that exists. If you want to do the research work, just simply go ahead and do more research work. If you have any questions right away, I can answer your questions, right? There is something called static inner class also. Like I'll say static class, my new tax calculator. Okay, something like this. Now there is a difference here. This particular element, I'm calling it an element. I'm calling it a member. Sorry, the right term in Java would be member. It's member, right? So member of a class. This is also member of the class. Come on, tell me something. This is also a member of a class or not? This public static void main is also a member of a class. This is another member of the class. This is yet another member of the class. I have, private int id. This is also the member of the class. These are all members of the class. Whatever you write within the class, these are all members of the class. This also is a member of the class, just that it happens to be a class again. This is again a member of the class. This happens to be a class again. So this is static. This is class based. This is static. This is class based. This is not class based, but instance based. Okay, many a times you do this in order to encapsulate the implementation of some logic within the class itself, and you will be reusing this logic here. I will give you some more examples. For example, let's take a look at something like map. Okay, map.java.util. Okay, map. Now this is what it is, an interface. Come on, yes or no? This is an interface, and you see this. You can see this entry, which is in the same map.java, but an interface. This is an inner interface. You got that? Interface entry k comma v. You remember that we did this map.entry. How will I refer to this map.entry? Come on, is it? This is a member of this. So be aware of the fact that not only the properties and the methods are the members of the class. There can be another class, and that can again be static or non-static. Okay. Take a look at this. I will give you all 30 seconds to recollect the discussions that we did on day one with respect to Java heap and the stack objects. You write code, you create objects here within your function. Please recollect, the reference variable is here, but the objects are created here. For example, take the example of customer. You see, new customer is created, so the reference C is here, but it points to an object here in Java. You just recollect. I will give you all 30 seconds. Recollected? Okay. Now, garbage collection in Java is automatic. You don't have to explicitly invoke it, though you can. Though you can. You can very well do something like this, from somewhere in your application. You can say system.gc. You can do this. You can very well do this. But you don't have to. It will automatically take care. In fact, you must not do this. Only if you have some good reason and if you know the adverse effect of invoking system.gc, only then you do it. Otherwise, you usually don't do it. And again, it is not guaranteed that the JVM will kick the GC based on system.gc, though more often than not it does, but there is no such guarantee. Okay, coming back here. So how does garbage collection work, and why is garbage collection needed in the very first place? Why is that needed? Because as multiple threads are running, note my words, as all of these multiple threads are running in memory, you keep on creating thousands of objects. You may not even realize how many objects you are creating. Thousands of objects are created, and those objects are all created in heap. Don't you think eventually the size, there is a limitation of the size of the heap, right? I will also show you how do you set the initial size and the max size of the heap. So there is some specific size of the heap. Once the heap is full, what is the kind of error that you will get if you still further try to create an object? What do you think your Java virtual machine will throw? What kind of an error it will throw? Come on, tell me. What kind of error will it throw? I want to see that in the chat. What do you think? It will run. Don't you think it will run out of memory? I'm giving you hints. Don't you think it will run out of memory? Tell me what kind of what error would it throw? So if you think, okay, tell me. Yes, out of memory error. Very good, Rakesh. You all agree, friends? Very good. Yes, yes, Deep. Out of memory error. Perfect. Out of memory error. Yes, correct. So now listen to this. What Java does. Listen to this. What JVM does. Okay, good. Listen to this very carefully. It's a rapid thing. Okay, not that you cannot ask questions, but accumulate your questions. I will answer your questions also in a rapid fire way. Okay, so just note down your questions somewhere. Okay, don't shoot it now. I will give you all a chance to. Or else you type your questions. Don't hit the enter key. Don't hit the enter key. And after some time, when I give you the question answer time at that point of time, just hit the enter key. Okay, now listen. Now listen. So whenever an object is created, there is something called memory manager within Java. Within the JVM, there is something called memory manager. It is the responsibility of that memory manager to allocate memory for the new object that is getting created. In order to allocate memory, it will refer to free list. Don't worry about what is a free list. Just understand there is a data structure called free list internally maintained. That free list helps the JVM, rather the memory manager in the JVM, to understand that which memory ranges are available in order to create the new object. In other words, it understands that there is some space available or not in order to create the object in the Java heap. If it fails to find the space that is needed to create an object, it will run garbage collector. I can write a book on garbage collection. All praises be to God the Almighty. Sorry, I'm not blowing my trumpet. So once again, the will JVM has a component called memory manager. That memory manager will refer to some data structure called free list. From there, it will get to know whether it has some space available in Java heap to create an object or not. If yes, it creates the object. If no, it will start garbage collection. It will pause your application threads, not my words. It will pause your application threads. In brackets, yes, there are concurrent garbage collectors also, which will not pause your application threads for throughout the duration of garbage collection. That's a different story. But then otherwise, it's usually stop the world. It pauses all your application threads. These are your application threads, and it will kick in garbage collection. Garbage collector kicks in. It sees those objects which are referred to from the stack. It sees those objects which are referred to from the metaspace. It marks those objects as root. For example, this C is a reference variable in the stack, and it will mark this object which is being referred to from the stack as the root object, as the root object, correct, as a root object. And then from the root object, it will start tracing to the other reachable objects. For example, customer object may have something like city, so it will trace city object. So maybe there is an object over here, see, and there is a variable here called city. Within this here, right, you can have, right, customer ID of the customer, the name of the customer, the city of the customer. So that city will be a reference to, I like rounded shapes. Okay. Okay. It will refer to the city object. So this is a city object here. This is the city object. Correct. And then it's quite possible within city you have state variable. So state object is there in memory. So this state variable within the city is pointing to the state object. So this is the object of class state. This is the object of class state. So what it does is that, once again, the garbage collector kicks in, it gets all the objects that are root objects. Then from the root object, it starts tracing, very technical term, starts tracing to the other reachable objects in heap. I repeat, from the root objects, it starts tracing to the other reachable objects in heap, and it will mark those objects also as reachable. So it understands in each and every object internally, you cannot see that, you cannot access that. Internally, there is a bit field which has a marker whether it is reachable or not reachable. It will mark those objects as reachable. All the other objects which is not marked as reachable through this process are the ones that are garbage. Simple common sense. Those objects, because I did tell you there is not even a single piece of code, not even a single line of code that is executable, and it does not execute in a thread. It does execute in some or the other thread, either in the main thread or T2 or T3 or T2, in some or the other thread. I'm sorry, all the names are same. Hey, how can it be? The other threads, right? T5, for example. So n number of threads are running. thousands of objects created. You have reference variables from the stack. There are static variables in the permanent generation in the object of class. From there, it is referencing objects here within the heap. And from the objects which are already there in the heap, from those objects that are other objects that are reachable, all these objects are reachable. They are of use. They are reachable. Rest that are not reachable are is garbage. Now, one would say, how come? Which kind of objects will not be reachable? Don't you remember? We said main function is pushed into the stack. From main, maybe you called F1. F1 is pushed into the stack. F1 starts executing. From F1, you make a call to F2. F2 is pushed into the stack. F2 starts executing. So now note my words. From F1, you might have created an object. From F2, you might have created an object. But F2 completes, it is popped out. What resumes is F1. F1 completes, F1 is popped out. What resumes is main. So F2 and F1 are popped out. That means the local variables and the reference variables in F2 and F1 are lost. So the objects that were created in heap are not reachable because F2 and F1 are no longer there. So the reference variables that were there in F2 and F1 are not available to, with the JVM at all. They are lost. So the objects that were being referred to by those reference variables that were in F1 and F2 function, they are lost. So such objects are not reachable. Note my words. These are the objects that are reachable, whereas those objects are which has lost reference are not reachable. So those objects will be collected. I repeat, those objects will be collected. What do you mean by collected? Will be removed from memory. Will be removed. And the right technical term will not be removed. Actually, the memory of all of those non-reachable objects will be claimed back and put into the free list. Come on, guys, you all are all engineers. Try and understand. Nothing. These things shouldn't be advanced or difficult for you at all. Pretty simple stuff. You all have cleared your engineering, right? I'm telling you all, it is simple for you. I'm telling you, very simple stuff. I'm saying those objects which are not reachable will be claimed, and those memory addresses will be put back into the free list, so that now that memory can be reused in order to create new objects. Simple, right? That's how it is. So this is how garbage collection works, and garbage collection is the process of claiming the memory back of those objects which are not reachable so that new objects can be created. But then it is quite possible you keep on creating objects, and you hold on to the references of that object. Maybe you create some kind of a map and you keep that map in memory and you hold on to the reference of the map, and map in turn, refers to 10,000 objects, and memory becomes full. You are going to get out of memory error. But before that, your JVM will certainly run garbage collection. And even after running garbage collection, it sees that still there is no space. You are holding on to the references of 10,000, or I mean, I'm just saying 10,000, but thousands of objects which cannot be claimed. It has valid references. It cannot be removed. It shouldn't be removed. It cannot be removed. Then in that case, and still, if you're trying to create an object, and if there is no space, it will throw an out of memory error. I will give you not more than 5 seconds to ponder over this and ask questions if you have any. Rapid. You know what are packages, right? Okay, I promised 5 seconds of. Come on, tell me. Java has auto. Yes, Anand, वही पूरा explain किया अभी मैंने. That's exactly what I explained. It's automatic, right? You don't have to. You don't have to explicitly say system.gc. You don't have to explicitly tell JVM to start garbage collection. I said the moment it starts, you create an object, it tries to allocate memory. But if at all it fails to allocate memory, it will run collection. I mean, it will run garbage collection so that it can free up some space. No, I'm sorry, Anand. You can ask any questions, and your question was valid. Answer to your question is yes, it's automatic. I'm sorry, don't feel offended. Anikendu, sir, please explain F1 and F2 part again. Yeah, see. See, what happens is that you remember earlier, I did mention that you got a main function. From main function, you may make a call to. Okay, let me explain that again. Suppose this is the thread. Okay, and in this thread, you have a function. You have a function called, run is the function from which this thread starts. From the run function, you make a call to another function called f1. Okay, so f1 will be pushed into the stack and f1 will start executing. You remember we did discuss this. Then from f1, suppose you make a call to f2. So F2 will be pushed into the stack and F2 starts executing. You remember this? We did talk about it. Sorry, F2, right? I'm just giving an example of F1, F2, F3, but it can be any function, of course. From F2, you make a call to, a function called F3, F2. F3 is pushed into the stack and F3 starts executing. Now F3 gets completed. It's popped out. What resumes? F2. F2 gets completed. It's popped out. What resumes is F1. F1 gets completed. It pops out. What resumes is run. Run completes. It's popped out. Now this thread is terminated. So at any given point of time, suppose this is the state, F3 is executing, but F3 is completed, it is popped out. So all the references that were there in F3 that were pointing to the objects over here is lost. So those objects that were being pointed to by references in F3, just because I have, as a result of losing the references, the objects over here are no longer reachable through those references because that reference is lost. I cannot reach to this object. It's this object is not reachable now. In such a case, it will be garbage collected. You got that, Anikindu? Okay, super. Right. Fantastic. Fantastic. Okay. Now another point. So you have yes. So another point that I'm supposed to talk to you about is okay. How about packages? How about packages? Packages are what you see. We have already done that. We have been creating our classes in packages, and if you want to access any class from another package, you need to import it. As simple as this, my dear friends. So if suppose I am in basic, my customer is a class which is in assignment one package, and if I'm here in the basic inner class demo, and if I want to use that, so I'll say customer. I say customer. You see this is there in that package, and you see this automatically the import statement comes up. Very simple stuff, but very important point. If there is any member that is declared in a class which is package specific, listen to this. All of friends, listen to this very carefully. If I have a class here, customer, see this class customer. And what are the different modifiers? I can have public, private, or protected. Public, accessible from anywhere. Private cannot be accessed from anywhere other than the class in which it is declared. Protected. What do you mean by protected? If I say protected and I say, let me create a function protected, I'll say void, I'll say display name. Suppose this is the name of the function protected void display. Now, can this be accessed from the customer itself? Yes, needless to say, yes. Can it be, can this be accessed from another class in the same package? I go to sales app, I've got a customer object, and you see this, I say a customer, correct, very good. A customer dot, I say display name. Can I access this? Yes, I can. Right? Can this be accessed from out of the package? Can this be accessed from out of the package? Okay. Okay. So let me go to employee app. Let me create customer. Okay. See this now. See what I'm doing. I'm saying in the package. Well, even after importing. So okay, see this. I say customer is equal to new customer. Okay, I import. After importing it, okay, fine. That's exactly. Oh, oh, sorry. This is abstract, right? So for the time being, I will not make it abstract. Oh, I'll have to change everything. Okay, I will create another class. Come on, forget about that. So I will have another class called uh, class, and I'll say uh, supplier instead of customer. I'll say supplier. Come on, simple stuff. Supplier, and I will say protected. I will say void display name. Okay, this is the function. Okay, simple supplier protected name. Okay, forget about this now. So this is abstract. This is abstract, and I go back to your employee app and I remove this. Okay. Okay, so far so good now. So I'll create supplier. So from sales app, can I use supplier is equal to new supplier? Can I do this? Yes. Can I say supplier dot display name? Yes. No issues. I can do this. I'm going to employee app, and from here I say supplier. Okay, supplier. I'll say supplier is equal to new supplier. Okay, cool enough. Can I do supplier dot display name? Can I do this? I cannot. I cannot because it is package protected. See, display name has protected access. I cannot do this. I cannot use it from out of that package because supplier has protected. I cannot use it from out of the package. I can use from anywhere in the package, but not from out of the package. But, but, so let me comment this. But let me comment this. Now I'll say Java class, okay, special supplier, some class like special supplier. And the special supplier extends supplier, right? Extends supplier. Got that? And here I have some another function. Say, for example, I'll say public void, okay, display all details, something like that. And here I say super dot display name possible. Yes. Though I am not in the same package, I am in the basics package, whereas this is an assignment one package, and this supplier has display name which is protected. So it cannot be directly accessed from out of the package, but it can very well be accessed from out of the package in the class that extends from that class. Got this? So you got to remember this, right? I'm putting a comment here so that this goes as reference material for you. Protected can be accessed from out of the package, only in inherited, only in classes that are inherited from inherited. Okay, from the whatever you understood in inherited, right? Okay, fine. And here in this case, following cannot be accessed directly as display name is protected in assignment one package. Hope you got this, friends. Right? Okay, let's move on. So, okay, local inner class and stuff. That's fine. Okay. So in this inner class, there are loads of things that you can do. I mean, can't you very well have members now within this class itself? I can have private members, I can have protected members, I can have public members. Can't I have public, private, and protected here? Yes, I can have that, right? And then this can be, private static class. That means it cannot be accessed from out of the class. This can again be private class, which cannot be accessed from out of the class, which is perfect, right? So this is local to the class. And again, if I make this as protected, I can very well say protected class here. I can very well say protected class here, So it can be accessed from anywhere within the package, but not from out of the package, right? That's how it is. We did talk about anonymous inner classes, right? Yesterday, while talking about interfaces, you remember we did talk about anonymous inner class. I just call it anonymous class. You may also call it anonymous inner class, because this is actually, an inner class gets created, anonymous. dynamically. You got that? Right? Okay. Exception handling, we did talk about exception handling. Okay. Now, about exception handling, let me tell you about exception handling. There is something that I need to bring to your notice. What if this account class has got multiple validations? You remember this account class? You remember this yesterday? We did work on this. Okay. Insufficient balance exception. Yes, correct. Super. And suppose it has yet another validation, and that validation is like negative balance exception. Maybe you have or credit limit expired exception. Maybe you have a concept of a special account, current account, which is a business account, wherein overdraft is allowed. Overdraft means you may have balance as zero, you still issue a check to your party of say 5 lakhs. Bank says we have given you the credit limit of say 10 lakhs. So you have a credit limit. You can keep on issuing checks to the limit of last is 10 lakhs. So even if you do not have 10 lakhs in your account, they will still clear the check and they will charge you interest amount for the money that is overdraft. That's called the credit limit. So suppose there is some kind of a, but of course there is a limit. So suppose this is the account and private float. Okay, credit limit of this account is suppose say 10,000. Okay, and then you need to check over here if the amount, okay, if the amount is greater than, so after this balance is done, after the withdrawal has happened, I mean not after, but actually withdrawal has happened, and then whatever the balance is, if the balance, now see, this is the logic, right? If the balance is less than, sir, we can't have protected class. I just wrote that right in front of you. Here it is. See, I did write protected. Why can't? It's yet this the classes within a class are just yet another members of the class as same as, right? Yes. Okay, so coming back here, if the balance is really less than, okay, 10,000, okay, or whatever the logic is, right? If it is less than, okay, or if the balance is greater than minus of, you know, minus 1 into whatever is the credit limit, correct? That's how it is. Then in that case, if it is, okay, this line is not reachable at all, because yes, you see this here, return balance, and then I'm throwing an exception here. So, it's not possible that it will reach here at all. So I'll go back and I'll put it over here, right? Perfect. See this? So if balance is greater than, minus of credit limit, then in that case, the credit limit has expired. Maybe the logic is right or wrong. Don't worry about that. In short, we are checking whether the credit limit has expired or not. Well, this logic is not important. Maybe this if statement that I have put is not in line with our requirements, but then that is not what we are discussing. What is important is that if this is the case, you throw another exception, right? You throw another exception, and what that exception is, okay, you do this. This IDE is superb. Suppose if you have closed everything, you are on this class, and if you want to get to that class in the tree view, then in that case, you just need to do this. It will take you exactly to that class. So you see, I'm going to create yet another class here. I will give the name of the class as credit limit reached exception. Okay, and what is this supposed to be? Extends from exception, right? I'm just keeping it as it is for now, and you see this now. See this. What am I going to throw here? I'll say throw new credit limit reached exception, and I will pass some message, and that message would be what? The message would be credit limit reached, isn't it? This is what I'm going to do. But of course, I have not yet created this constructor. So let me create that constructor, credit limit reached exception. That's the constructor I have. I'll say public, and I'll say string, I'll say message, and I'll write super message. I'm calling the super constructor here, friends. See, this is an example of calling the super constructor, right? So here you go. Correct? Perfect. Now, what is it? What do you think I will have to do here? What do you think I'll have to do here? See, it very clearly tells you. Take a look. What is wrong here? Come on, come on, come on, fast. What is wrong here? No, no, not the catch. Not the catch. No, 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 not the catch. It's just very clearly telling you. You must give throws, right? Otherwise, how will the client know? So I'll say credit, yes, the method signature. Now this is perfect. No errors, you see. But then now why it is giving me still, this is not a compilation error. Hello, I've been saying this since couple of days that this is not the compilation error. This is the extra feature that the IDE offers to you, saying that there is something wrong. You're using this method wrongly somewhere. So I know that. I go to account tab and you see this here. Now this withdraw money, this withdraw, I'm catching only one exception, whereas it is throwing two exceptions. So I'll have to have another catch, and I will say which exception. Come on, credit limit reached exception. I can again say EX, and then here I will do something, and I'll say EX.get message. Got the point? So this is one way of doing it. But then, from Java 1.5 onwards, you can have, instead of this, you can have multi-catch. What does this mean? I may not write this. Instead, I will use a bar here like this, and I will say credit limit reached exception. Okay. Okay, EX. See this. This is also possible. So either this or that, either this exception occurs or this exception occurs. This is the catch block that I want to execute. So I don't care which one of the two exception has occurred. I don't care which one of the two exception has occurred. This is the single catch block. This is more convenient. This is more elegant, as compared to writing multiple catch blocks. This makes my code more precise and concise. That's the only additional thing. You can have a nested try block also within a try. Can't I have a try within a try? Can't I have a try again? I can. Okay. I can have catch or at least finally. You know what is finally? What will finally do? Finally will 100% execute whether there was an exception or if there was no exception, right? So I can, if I write finally over here, this piece of code finally will always execute, will always execute whether there was an exception or not. Okay, finally. So if you want to close some resources, if you want to do some cleanup work and stuff, you can very well do that in finally block. Okay, how do you print the stack trace? What if you want to print the stack trace? ex.print stack trace. This will give you the entire stack trace. What do you mean by stack trace? Come on, what do you mean by stack trace? You remember we talked about run makes a call to F1, F1 makes a call to F2, F2 makes a call to F3. So there are so many functions that are there in the stack. Now, if suppose F2 made a call to F3, so this is F3 function getting executed. Okay, F3 makes a call to F4 and F4 is getting executed, and from F4, suppose from F4 there is an exception. There is an exception happening in F4 and you are printing the stack trace. It will give you the entire trace. It will tell you from which line in run you made a call to F1. From F1, from which function and which line made a call to F2. From F2, which line made a call to F3. From F3, which line made a call to F4. And now the exception has happened. That will give you the complete stack trace. It is extremely important for debugging. Extremely important for debugging, okay, in many cases. But be careful, make sure that your stack traces are limited, and in the production environment you don't do it in the production environment a lot, otherwise your log files will get filled up badly. Okay, any questions? It helps developer to know what happened. Yes, Likita, very correct. Yes, Parthia, whatever exception happens finally will certainly get executed. Okay, so data structures. We talk about collections. Wow, we talked about auto boxing and unboxing, isn't it? We talked about auto boxing. What is unboxing? Getting the value. Getting the value, right? See? So if someone asks you, what is unboxing? Tell me what is unboxing. See, after this training, how would I rate the success of this training? How would I rate? You can all see me? You can all see me? Yes, yes, I can see that you all can see me. I can see my video here. After this training is done, my dear friends, you must be sitting like this. ऐसा दिख रहा है? पैर पे पैर चढ़ा के ऐसा. Yeah. Tell me about Java. Come on. What do you want to ask about Java? That's how. That's the style you must have. Got it? Okay. Yeah, changing wrapper class objects to primitives. Yes, Gaurav. Yes, Gaurav. You are bang on. You are spot on. You are right. So, suppose, just giving you an example, somewhere in some. Okay, let me go here. So, you remember that? You remember this? We talked about integer, age is equal to 25. Okay, we talked about it. This is my age, 25. So, okay. So integer age is equal to 25. Now what is happening here? It's auto boxing, This is going to auto box. Automatically, it's going to box 25 into integer, isn't it? It will automatically box this 25 into an integer. So you see age dot, when I say unboxing, as Gaurav rightly mentioned, from the wrapper class, getting the primitive value, I say int value. This is not an object, this is primitive. Okay, I'll say int value is equal to age dot int value. You got it? This is auto boxing. This is, and I did explain this in detail. In fact, I went deep into the source code and I explained how the auto boxing happens. Can someone tell me exactly in the bytecode what will be the name of the function? What happens in the bytecode? Which function is called in order to box this into an integer object? Which function? Come on, I'll be very happy. At least one of you all must answer. At least I did take you to the bytecode. You remember I did show you the minus 128 to plus 127. You remember? What was the name of? I did take. If you're really you're very fast and agile, you will go to the source code and immediately see. Control O. You remember? What was the name of the function? Bytecode बताया था मैंने आपको. What was the command I used in order to show you the operation code of the bytecode? भूल गए आप लोग सब. आप कैसे बैठोगे ऐसा पैर पे पैर रख के after this training? Yeah. Oh, you don't remember? You remember integer dot value of. You remember we used Java P hyphen C and the name of the class, right? To see the bytecode. Opcode, not the bytecode, opcode of the bytecode. You remember? अभी कुछ याद आया? See integer, right? You remember value of. Remember this? याद आ गया? Correct. Good. Array lists. We have talked about arrays. We have talked about lists. We have talked about date and time. Date and time. अभी इसको सुन लो अच्छे से. Don't miss this. Okay, don't miss this at all. Don't miss this at all. What's the time? Wow, we've got good amount of time. What's the time? It's still okay. What is it? What are we talking about? Date and time. Sorry. So I'll say Java date and time. This is the package. And see, the package names must always be in lowercase. Huh? Never, it must never be in camel's caps. It must always be in lowercase. Okay, always remember that. Okay, so I'll say class and I'll say date, time, demo. See now, again, this is a rapid fire. आप लिख लो ये. There is and इसके अंदर कुछ ज़्यादा समझाने जैसा नहीं है. I mean, there is nothing and nothing huge to explain here. It's pretty simple stuff. This is something. This is there. Since inception. You see, date class. So I say date. You can see this java.util.date, right? And I can say date is equal to new date. Simple, right? And this is also rich, but there is a problem with this. So I'll say date. You see, I will be able to now. If I run this, I'll get date. current date. By default, if you try to create an instance, not try to, you do create an instance of day, you get the current date and time. You can see this. You're getting it over here. Perfect. Simple. Okay. Now you can do loads of things out here. You can say date dot get time. This will give you, what, my dear friends? आपको मैं एक चीज बताता हूँ. I will tell you one thing. Time. How is time represented in your computer? How is time represented in your computer? You all are missing a point. You all are missing a point. I did mention this right on day one. Everything that is stored in random access memory or any kind of memory, whether it is permanent storage on your hard disk, or it is in random access memory, or it is in read-only memory, ROM, whatever, wherever, if it's memory, the data is always stored in primitive types. The string and whatever you all are mentioning here, the string and all, these are classes. These are convenience classes. These are not. This is not the format in which the things are stored in memory. How is time represented in computer? I didn't say Java. I didn't say .NET. I didn't say TypeScript. I didn't mention any programming stuff. I said computer. It's stored in long. Long is the primitive type. लिख लो. लिखो आप लोग तीन तीन बार लिखो. Time is represented in long, always in computer. तीन बार लिखो ऐसा यहाँ पे. All 23 of you. Okay, it's okay, it's okay. Just kidding, just kidding. Don't forget this. Okay, remember this. Time is always stored. Any architecture, any hardware, any operating system running that hardware, time is always stored in long. So if you want the long value of time, okay, see this. And time is passing. Hello, friends, time is passing. See this. This is the long representation of now. Okay, I'll show you something now interesting. I'll say while true, or else I'll say for int I is equal to 0 until I is less than 50, I plus plus. Okay, and I will say date d is equal to new date, and then here, so I will not print this, I will not print this, and I will write here, okay, I'll write system.out.println and d dot get time, and I'll say thread dot sleep, so the main thread will sleep for 1 second each time before it goes back into the loop. Now see this. Time is passing by. It will never be the same, right? See, 93, 98. Now, you may think that it should have been, 1, 2, 3, I mean, 93, 94, 95. No, if that is 1 second, then yes. And agar 1 second, if I keep 1 second over, I mean, say 1 millisecond, then in that case, it will run so fast, we won't be able to see it. So it's 1,000 milliseconds that we are giving. And it is in terms of time, is in terms of, long milliseconds. It keeps on. In fact, it's the data type is definitely long, but it keeps on. So see, new time, right? It's not maintained in seconds. It's maintained in it's maintained in milliseconds, right? In fact, not even milliseconds. Yes, yes, milliseconds if I'm not mistaken. Yes, but the data type is long for sure, as you can see. You got this right? So this is how in computers, whichever hardware, whichever operating system running on top of that hardware, time is always stored in long, and long data type has a limit. Okay, long data type has a limit. Now I will comment all this and I will show you system.out.println any data type, like any numeric type data type. I can very well say, like for example, long max value. So this will give me the max value. You see this? This gives me the max value. You got that. and the max value will be reached. This max value will be reached in 2032. Hello, friends. This max value will be reached in 2032. So what will happen about what will happen of your computers in 2032? I don't know. Let's proceed. So so that's how it is. Okay. So yeah. So this is there. So if I take you to date, as you can see, it's there since JDK 1.0. Since inception. You all are all there with me, right, friends? Please confirm. All there with me. Okay. Good. So you see this, it's there since inception, JDK 1.0. But from 1.8 onwards, I repeat, from 1.8 onwards, they introduce. Why? Because there is a problem with date, huge problems, in fact. Okay, there is yet another component that you must know of. Calendar. We used to use this. I'm saying used to because we have stopped using it. Calendar C is equal to calendar dot, I'll say get instance. Right? New calendar, take a look. I say new calendar, not allowed. Why? Because it does not have a, you see this? This is protected. If the constructor is protected, can it be used from out of the package? No. And the package in which it is, this is there in which package? Calendar is there in java.util package. So I cannot say new calendar. There is a factory method given. Repeat, what method given? In fact, sorry, this is not based on factory. This is singleton. Repeat, please type fast. Jaldi jaldi type karo. This is based on singleton design pattern. Jaldi, singleton design pattern. Type karo fast. Singleton. I hope you all are sitting, with your hands on the keyboard. Singleton. Yes. So it returns to me a singleton. Perfect. Now I can use this calendar very efficiently. I can add a field. That means I can add a month. I can add a year. I can add, seconds and so on. I can get year. I can get, I'm sorry. I can get year. I can get day. I can get day of the week and so on. Using get, I can get get time will give me the long format of it, and I can do arithmetic with date after so and so date, before so and so date, and then I can also roll the calendar. Very interesting and very important. Roll the calendar. Suppose in your application you've got a need. What will be the date after 30 days? What will be the date after 50 days? Suppose you have got a simple requirement that when the invoice is created, the date on which the invoice is created, exactly 45 days after the creation of the invoice date must be the due date of the invoice, and you need to store the due date. How will you calculate the due date? 45 days kaise milega? I mean, how will you get the day on what will be the date after 45 days from today? How will you get that? Or from any given date, what will be the date after 45 days? How will you get that? You cannot keep on whether it is, if it is January, then add 31 days. If it is February, then add 20. But and if it is a leap year, then add 29. Hey, come on, you cannot do that, right? You wouldn't want to do that. So you just say roll. When I say roll, field, which field? Days. Boolean up or down. I want to go back 45 days back, or I want to go 45 days ahead. I can roll, right? And how much of rolling up that I want. So all of these functions are available. The roll will help you to roll the calendar, right? That's how it is. But you know what, there are serious problems with this. They are not thread safe. Now if I get into thread safety, I will again get excited about the topic, and I will end up spending 1 hour on it, which I don't want to do. Thread safe, just giving you an overview. Thread safe means multiple threads changing the state of an object. I repeat, multiple threads changing the state of an object, and still each thread getting the perfect and the latest value is what thread safety is all about. So it's not about safety of the thread, it is about the safety of the state of the object that is being updated from multiple threads. I repeat, what do you mean by thread safe object? What do you mean by thread safe component? What do you mean by thread safe class? To be very generic, what do you mean by thread safe class? The class, you create an object of that class and you update the state from multiple threads exactly at the same point of time concurrently at the same point of time, and still both the threads will get the latest value, not the stale value. That means this class, the object of which is created and the state of that can be updated, is thread safe. Okay, it's called what? Thread safe. Okay, I'll say class here, thread safe objects. Okay, some of the thread safe objects are here. Okay, okay, thread safe objects, or okay, so I'll say not thread safe, not thread safe, right? I'm giving you the list of not thread safe. Array list is equal to new array list, not thread safe. Okay, hash map is equal to new hash map, not thread safe. I'm giving you some examples. Okay, these are thread safe. Okay, vector, it behaves like an array list. Okay, vector v is equal to new vector, this is thread safe. Hash table, okay, t is equal to new hash table, this is thread safe. Your date d is equal to new date, okay, not thread safe. Okay, now whatever is coming to my mind, as such, proceeding further, I am explaining, I'm putting it down. For example, you have a data structure called string buffer is equal to new string buffer, not thread safe. Sorry, string buffer, it is not, it is thread safe. But string builder is equal to new string builder, this is not thread safe. Correct. So wherever you don't need a thread safe objects, you don't use thread safe objects, and wherever you need, you will. Okay, well, so date has a problem. So what they did is and then what we used to do, and it does not have good time support. Okay, so let me put that over here. See what I'm doing. What problems are there? Not thread safe. One second is no good support for time zones. Time zones these days, since last 10 years we have been building applications which are web applications, used by people around the world. We deploy the same product, we deploy the same application in multiple locations. So the time zone is extremely important. Your application must support time zones. So there is no good support with, for as far as time zone is concerned with dates. So what we used to do, we used to use a library called Joda time. Please write it down fast, jaldi likho. Joda time. So we used to use what? Come on, Joda time likho. Joda time. सब लोग है ना मेरे साथ, अगर ऑल there, right? कोई एक तो लिखो. Good, good. Sabash. Yeah, because of network lag, it takes some time to come. Superb. I can see that. Superb. Joda time was used. We used to use. Today also there are many applications actually using Joda time. But from 1.8 onwards, not my words, from 1.8 onwards, you don't need to use Joda time, because inspired by Joda time, they have a complete package now with state of the art support for time zone and thread safe objects, and that is java.time dot local date. See, when was this when was this provided by Java? Which version? 1 point? Come on. 1 point? 1.8. Yes. So java.util.local date. So I can say local date, right? I say d is equal to new local date, local. I cannot say new. Hello. I can say local date dot now. Again, there is no constructor available, for local date. I can say local date time, right? I'll say t is equal to local date time dot now, right? And then I'll say local time. If I just want local time, then also here it is, time. Okay, T1 is equal to just the time part of it. I can say local time dot now. And it's very rich and it supports superb time zones, it supports time zones. So I'll say dot now. You can see there is an option of zone ID. So I want time from which zone? I can very well specify that, zone ID. I'll say zone ID dot off. I'll say, what is the zone ID of British time? I forgot. I'm sorry. British time zone ID. BST चलेगा. British summer time. If it's a wrong, yeah, if it's wrong, it will tell me it's unknown. I'll say GMT. I'll just say GMT. Okay. Greenwich Mean Time from London. It starts from 0 over there. Okay. Local date. Let me say time so that I get the time as well, isn't it? So I'll get the time in London now. It must be 5.5 hours behind. See, it's 9:30. No, it's yes, correct. So 17:05:06:17 T 05. It's 5 o'clock. My dear friends, it's 5 o'clock there. It's 5 o'clock there. You see, 5:44, not 5 o'clock, 44 past 5. That is around quarter to 6, isn't it? You got that? So rich support of time zones as well. So tell me, in your all your applications that you're going to write, you're going to use java.util or you're going to use java.time dot classes. Come on, what is it that you're going to use? Java.time or java.util.date? Yes, you will use the classes from java.time. Java.time is the package, and you will use classes from that package. Okay, we talked about sets, queues, and maps. We didn't talk about queue, but queue helps you to, traverse in a direction, and it gives you the feature of what is the typical nature of queue as opposed to stack. Yes, it's FIFO, first in, first out. Hash table and hash map, one and the same thing. I repeat, hash table and hash map, it's one and the same thing. But hash table is synchronized, hash map is not synchronized. That means hash table is thread safe, hash map is not thread safe. I repeat, hash table is, yes, it's thread safe. Yeah. Dictionary is map, it's properties and trees. Okay, you can also have properties wherein, you see, you have a class called properties. You can see this here. You can see the java.util.properties. What does it extend from? What does it extend from? What properties extend from? Hash table. Correct. It extends from hash table. So if properties extend from hash table, can I say it has all the features of a hash table? Yes, it has all the features of hash table. Yes. What is the additional thing that you've got in properties then? You can load the data into this from an external source. You can load the data from input stream. You can load the data from a reader, from a line reader, and so load from XML. You can load the data, the properties data from an XML file. Correct? That's what you can do. All right, properties and trees. Hash tree is what we have already, tree set is what we have talked about. Sorting and searching, now this is important. Now this is important. Color. Chalo, agar ye nahi aata hai, to there is a problem. If you don't know this, then there is a problem. So you see, we talked about collections yesterday, right? We talked about collections. And see, for example, we have this collection here. And, I don't want to execute anything further. So I'll just deliberately say if true, I say return. So what will this do? Will it execute the rest of my, rest of the part of my application? No, it will not. Return. Okay. So this will not execute anything beyond this. So it's just, it's going to print this. You remember this is the code that we wrote yesterday? Correct. Collections demo, right? So you see 123, 32. I want to sort this. How will I sort it? How will I sort it? Okay. So I'll say values dot, you see this sort, but here I will have to give a comparator. I will have to give a comparator. So instead of saying this, I can do collections dot sort. and I will pass values as the parameter. This will give me another list of what, okay, I'll just simply say sort values, and I run this. Now take a look at this, so I have passed that values as a parameter. I'm still getting to one. It's not in the sorted order. Why? Because it does not sort the existing data structure. It will not make any changes to this. Instead, this will return to you another list. You see, list of integer. I'll say sorted list. Right? Sorted list is equal to, hey, I'm so sorry. This sort is ah I'm sorry about it, my dear friends. I'm so sorry. I got confused, between this and the stream. Stream returns to you. I'm so sorry about that. My bad, my bad. Okay, so it does, you know, okay, you see, it does make changes to the existing collection itself. I'm sorry about that. It does make changes to the existing collection itself. So the moment you say sort, you say system.println before sorting, and this is after sorting. This is before sorting and the after sorting. Sort does not return anything. It's a void. I'm so sorry. I got that confused with something else on my mind. Okay, so you can sort very well. And searching. Can you search? How will you search? You'll say contains. It will return to you Boolean. So I'll say values dot, I'll say dot contains. And what will I search for? I will say, for example, 32. And I'll check whether this is true or false, whether it contains 32 or not. Take a look. So you will use contains. Okay, true. Because it's there. And if I say some other value, which is not there, of course, needless to say, it's going to be false. Right. Okay. Another interesting thing here. What if you have, all with me, friends? All with me? Was it right? It's 11:20. I'll give you all a break at 11:30. Okay. So, friends, please see this. This is the list of integers. Hello. This is the list of integers. What if you have a list of customer objects? What if you have the list of product objects? What if you have list of employee objects? Your sorting was based on the natural ordering. Integer it understands the value of which integer is greater than the other so that it executes the algorithm internally in order to give you, yeah, correct. So in order to give you, you know, in order to sort, and also in case of contains, in order to find whether the value is there or not, it checks. What do you think is the function it executes internally in order to check whether the values are equal or not? Come on, tell me. What do you think is the function that is used? Yes, it uses a function called compare to in comparable. I repeat, it uses a function called compare to in comparable. What does that mean? This integer is a class that is comparable. You see this? It is comparable. Take a look. String is a class that is comparable. That is comparable. Take a look. String is a class that is comparable. Double is a class that is comparable. You can see that double is comparable. Each one of these, see, long is a class that is comparable. You can compare it. Now what I'm going to do is I'm going to create here, right here in front of you. I do have a customer class somewhere in my application. I'll say customer C is equal to new customer. Okay. I'll say list of customer. I'll say customers is equal to, what am I going to do? I'll say uh, arrays dot as list, and I'll say new customer, comma new customer, and so on. I think there is no default constructor for customer. Customer, public. Once again, it's abstract. So I'll say new supplier, okay, new supplier, and I'll create a new object of supplier, new object of supplier. So you see this, I have list of supplier now. You can see this here. Yeah, correct, Likita, you're right. Comparator and compare to. So we have a supplier here, isn't it? We have a supplier here. But if I try to do collections dot sort, and I'll say, okay, let me change the name here to suppliers. And if I pass this as a parameter here, and I want the, I want, this to be list of suppliers. हाँ, ठीक है. Oh, it's smart and it is giving me an error here. This again is not a compilation error. I will get a runtime error. I'll get a runtime error. So please see this. Let me run. Now, so what is the kind of exception do you think I'm going to get? And what is the problem out here? What is the problem out here? Tell me. All right. See, you can see this no suitable method found. Can you see this here? You can see this here, right? Okay. Why? Because whatever you pass as a parameter here must be what? One word answer must be what? Take a look at my supplier class. Take a look at my supplier class. Just a simple class. Tell me what is the problem here? It is this supplier class is not, yes, it is supposed to be comparable. It is supposed to be comparable. So if you want to sort things, make sure that your class is comparable. So I'll say implements comparable. Right, that's how it is. Comparable on what? Comparable on maybe the ID. Two suppliers will be equal only and only if it has an ID. So for example, integer. Okay, I say integer. Right, that's how it is. Now if I do this, right, I will have to implement the methods here. You can see this. Correct. What does that mean? Suppose I have private int id. Okay, I have private int id, and then I also have a constructor. I'll say supplier. I have a constructor here, and then I say public, and then here I also have a constructor here which takes an argument of type int id, and I say this dot id is equal to id. Take a look. So in compare to, what will I do? What will I do? I will check whether ID is comparable to this or not. So what I'm going to do here is I'll say this O dot compare to what? This dot ID. Got this? See. So if these IDs, this is how it's going to compare it. So this will help it to sort. This is how it is, friends. This is what comparable is. Very simple. Now when I do this, right? Since it is comparable now why are you crying, baby? Well, that shouldn't be the reason. What's wrong? Ah, yes. I have, I think, yes. I guess compare to method. It dot equals, I guess, in compare to method. No. Here you have to return an int. Either it will return -1, 0, or 1. 1 means it's greater, 0 means it's equal, and -1, right? So, but wait a minute. Yeah, perfect, right. So I'm sorry. Though I want to, I mean, I have to decide this over here in this function. It's going to be compared based on which field of supplier. So I said, I will say O dot get, I'll say O dot ID dot, okay. Since it's an int, okay, let me change this to integer instead of int. I'll say integer, okay. And then I say O dot ID dot compare to this dot ID. Perfect, right? See, no errors. It works. Now I go back and run this again. Yeah, you're right, Pooja. That was the mistake. Right? So you see this now. This is okay. Of course, after doing it, I have not printed it. But if I print now again, if I print, I better make it two string so that it gives me the perfect value. So I'll say two string. I will overwrite two string as well. Okay, yeah. So supplier it automatically, this is the feature of the IDE. And I am going to now write as out suppliers. This will be sorted after sorting it. Right? So you see supplier 102 and 101. Okay, I have done the other way. I should have done this. This dot ID dot compare to, I will say O dot ID. Anyway, so this is how you will use comparable. You see 101 and 102. It's in the order. Even if I make changes here, if I put 102 first and then 102, it will give me in the order. So comparable, right? This is important. So I just luck. Right, friends. So now what I suggest is that you must, we'll take a pause. What's the time? It's 11:29, almost 11:30. We will take a pause here. I'll just give you 10 minutes today. Within 10 minutes, you wrap up your tea break and then we will come back. But in the meanwhile, let me commit the code. I'll say fast track. Yes, Kaushal. That's what I'm doing. Right, friends. So I have pushed all the code. Right. Right, friends. Come on. So let's get started now. Okay, also let me share my screen once again. Perfect. So, we talked about hash table sorting, comparing. Okay, Java generics. Now, you see, the next thing that I need to talk about is Java generics. Now, what is Java generics? Pretty simple stuff. Okay, so very simple stuff, right? Generics is what? This feature again was not available until Java 1.4. It was introduced in Java 1.5, generics, template-based classes, but in Java it's better known as, generics. In C, C++, it was known as a parameterized class and stuff, but in here it is better known as generics. Now, what is a generic? If I create, and the best examples are, the entire library of Java itself, the rt.jar file, which contains those thousands of classes and those hundreds and hundreds of APIs within the JDK library, they are replete with generics right here in front of you. List, this is a generic type. So when I say list, you see this, they have declared a list of a generic type. E extends collection E. Yes, exactly. This E, there is no significance of a particular character like A, B, C, D, E. It can be anything. It can be anything. So they select a particular character in order to define the template. So you see, whenever you create a list, it will be templated. That means the list will be of any data type, right? Any data type. It can be an integer. It can be a string. It can be a long, it can be a double, it can be customer class, it can be product, any data type, list of any data type, E, right? They could have used A also, B also. It's just that it so happens that they have used E, right? That's okay. So whatever the data type you use, like for example, here I said list of integers. So this E represents an integer runtime. If I say, list of string, this E represents the string runtime. Okay. And if I say collections demo here, you see this, I keep on adding the value. So how does that help me? It makes sure that unintentionally I don't end up violating the template. For example, values.add, if I say string, it's not going to work because you have already said that list is going to be of type integer. So this add function, if you go to the list and you see the add function, what is the data type of add? E. The same E. So E, whatever is the data type. So if you create of type integer, then it will make sure that the add function takes exactly that data type. So I say whatever, the value. Oops. Okay, that's how. And then you can see this add. So there will be many functions. Like for example, get is a function. What will it return back? What will it return back? E. Correct? This is what generics are. If you want to create your own generic class, can you? Yes, you can. You can create you can very well create your own generic classes. So let me create another package here, my dear friends, and then I'm going to say generics. Okay, and suppose I want to create a class, I'll say generics, generics demo. Okay. Now in this generics demo, I can also create a class for generics, and I can very well say any character that I want to decide. I may say whatever. I'll say T is the character, and then I can define some variables or some functions over here which will use that T. So for example, if I have my own function called print details, is the function, suppose void print details, I can very well accept an argument of type T. And I can say system.out.println and whatever it is, T, or I perform some logic, or I implement some logic, along with it, whatever, right? See, something like this. I can do this. So at the time of creating, the object, I say generics demo. You can see this here. I can say it is of type integer. See, I'll say integer. Now, the moment I say integer and I say, generics demo GD is equal to new generic demo here like this. Now, when I say GD dot print, it will never take anything other than an integer. Why? Because I have specified here T. So whatever is the generic type, it is only that type itself. So I can pass 3 as a parameter or anything that conforms to the signature, right? Anything that conforms to this template. Simple, very simple. And you will find your entire Java library, in hundreds and thousands of places, it is replete with generics, right? So this is what generics are. Of course, it's quite advanced. There are many things, extends, and then super off and extends and all this stuff is there. You can have bounds created for generics and stuff. So for example, you can say that I can take anything as a parameter over here that extends from T. So I can pass anything as a parameter that extends from T and so on. Well, so you've got generics here like this. And then lambda expressions, we have talked about lambda expressions. We have talked about, okay, lambda versus objects returning a value from lambda. We have discussed about that. Lambda versus objects is what, lambda expressions also are actually nothing but they are function objects, right? And method references. Now, see this. You remember this, right? Yesterday we worked on this, correct? And suppose you have some logic to implement. You have some logic to implement. Now this is important, really. I mean, trust me, you're going to come across this many places, many a times. Okay, so please see this very carefully. So I have given an expression here like this, a simple expression here like this. Okay, x comma y plus 2.3f. This is what? Why? Because my tax calculator takes two arguments, binary, two arguments, binary, right? It takes two arguments. That is the reason I've given this. But it's quite possible in some case, I may have something like this. If it is a simple expression, then you can write it in the simple line. But it's quite possible that you may have a complex logic to execute, maybe 3 lines, 4 lines, maybe 5, 10 lines of logic, right? And then finally you return the value or like this, and you write some statements here. Maybe you write 5 lines, 4 lines, there is some logic to be implemented. So far, so good. Are you clear on what I'm trying to say? You got my right? You understanding, right? So if it's one single expression, you don't need to open a bracket, you don't need to close the bracket, you don't need to write a return statement. I repeat, if it is just an expression, don't open a bracket, don't close the bracket, don't write the return statement, just the expression. But in some cases, you have some 3, 4 lines to write, some 5, 6 lines to execute, and then finally arrive at some conclusion and some calculation, and then you return the value back. I'm hard coding, but assume that I'm not hard coding and executing some logic and then returning the value. In such a case, you have to open a bracket and close the bracket and write the logic over here. So this is point one. Second point, it is quite possible, that this logic is needed in many places. This logic is needed many places. So will you be writing again and again and again and again? No, it doesn't make sense. So whatever you have written over here, maybe 5 lines of code, but if you want to reuse it 3, 4 times, then again, will you make your code, will you duplicate your code? It doesn't make sense, right? So what you do is that you will create a function. For example, you create a function. And in this case, what is the contract? What is the contract of this function? It takes two arguments and returns a value. I repeat, it takes two arguments and returns a value. So I will create a function which returns a value of type float, right? This calculate tax returns what? It returns a float, correct? So I'll say public float, and I'll say generic calculation, right? Or I'll say, don't get confused, I'll say general calculation. And it takes two arguments. Okay, the first argument is string x, and the second argument is float base tax, something like this, and the string is like state. And then I implement that common logic here. Whatever that common logic is, right? So this is base tax, and I'll put this base tax, and I return some value. Now, how do I make use of it in an expression here like this? I can refer to this method again, Java 1.8 specific feature. So either I can do something like this. You see, I will comment this code and I will say return. Okay, where am I writing this code? I'm in static, right? So let me make this also a static. So I can write return invoice dot, I say calculation, and then I will say I will pass that x comma y as a parameter. Okay, na? Take a look. Tell me if you have any questions in this. Simply calling a function instead of writing that code here. I have written that code here now, so that many a times I can make call to that function. Whenever I need, I will make call to that function. Any problems in this? Any problems in understanding this, friends? I will wait for a few seconds. Take a look. Simple. Instead, because I wanted to reuse, because this code I will be reusing many a places. General calculation I will be using many a places. So if I just invoke the function, that's it. Pretty simple. So this is one way, and I'll keep this as it is. Another way is, instead of still saying x comma y and passing a parameter like this, I mean opening and closing the bracket, and then saying return return whatever the function is. Instead of doing all of this, tell me which code do you see over here which is more elegant. Okay, you may say you have just written still same thing, same stuff, right? I've just removed that commented line because all that logic is here now. Okay, what do you think? Is this more elegant, or generate tax slips and I say invoice double colon? Which is more elegant? Tell me. This is more elegant or this is more elegant? One and the same thing. This is called method reference. I am referring to general calculation of this class. Tell me which one of the two is more elegant. The one which is on line number 38 or the one which is on line number 44? Right? The second one. And what is this known as? This is called method reference. Right? I have used static reference. It can be an object double colon and stuff. Correct? Right? Correct? I'll give you yet another example. We worked with collections and we have been printing the values, isn't it? Suppose I want to loop through this. Suppose I want to loop through this. You see, I'm printing the values here like this, but I don't want to print the values like this. I want to print it, on next line. So I will say for loop here, right? I will use a for loop. I'll say for. I'll say, see what I'm doing. I'll say for. I'll say string, integer. I'll say v in values. This is the normal for loop. And I'll say v. This works. This will work for sure. Come on, this will work or not? Simple, right? It's a no-brainer. Here you go. 65, 32, 12, 3, 23. This works. This loop works. But now see what I'm doing. Instead of doing this, I'll come in this. I'll say values dot for each, which takes a consumer. Which takes what? A consumer. What is a consumer? Consumer is a, what is a consumer? Consumer is a functional interface. Consumer. It's a functional interface. It takes two parameters and returns nothing. It takes one parameter, returns nothing. I repeat, it takes one parameter, returns nothing. Now this, see the system class. Right, in this you see out is an object of type print stream. Print stream has got a println function that we use day in and day out. You see this println, right? What it does, it takes one argument and returns nothing. So this, it takes one argument and returns nothing. It confirms to the consumer interface. It takes one argument and returns nothing. Come on, yes or no? See, consumer, it takes one argument, returns nothing. Print stream takes one argument and returns nothing. So I can say for each, it takes a consumer, one argument, and returns nothing. I won't write a return statement, but I can write system.out.println x. I can do this, which is good. Okay, no problem. So I can use a consumer, gives one argument and returns nothing. There is no return statement. I have written system.out.println. Instead of that, I'll say values dot for each system dot out double colon println. Which one is more elegant? Tell me, of all the three, which one is more elegant? Tell me. The third one, isn't it? The third one. Yes. Correct. What is this known as? Method reference. I repeat, this is known as method reference. Method reference. All right. All the three are great. All the three are good. It's just the elegance. Right. This is called syntactic sugar. What is this known as? Syntactic sugar. Right? You're making your code sweeter to read. No, I'm not inventing my own stuff, my dear friends. I'm not inventing my own stuff. Syntactic. Syntactic sugar. Okay, see. You can see this in computer science. Syntactic sugar is syntax within a programming language that is designed to make things easier to read or to express. It makes the language sweeter for human use, right? So this is syntactic sugar. You got the point? Okay. Okay, right. So this was about method references as lambdas. Okay, come on, let's move on. So the next is reflection API. You remember we did talk about reflection. You remember that? Once again, I'll say package and I'll say reflection. You remember, right? We did talk about reflection. Good. So within reflection, so what is reflection, right? I'll say reflection demo. What is reflection? Reflection is the way to introspect on the structure of the class. What do you mean by structure of the class? Like for example, we have classes here, like customer is a class or employee is a class. So what all are the properties? What all are the methods? What is the signature of the method of each and every method? What is the data type of each one of the signatures? And then, all of this, this is what? What is this? This is the structure. Everything that you have within the class is the structure of the class. So my statement that I'm making is this. What is reflection? Reflection is to introspect on the structure of the class. Okay? This is what it is. Introspecting on the structure of the class. So yesterday I used class.forName to load the class. That is one way to load the class. And there are specific use cases for class.forName. I repeat, there are specific use cases for class.forName. All such. Shukriya. Okay. So class.forName, if you want to dynamically load the class, if you cannot anticipate the name of the class, compile time, then you would pick up the name of the class from some properties file and you load the class, you instantiate the class and so on. But then otherwise also there are other ways of getting the reference of the class. And you cannot do the introspection till the time you do not get the reference to the class. You need the reference to the class, right? You need class reference. So one way is that you say class.forName and some class, whatever the class is, I'm just whatever the class is. Of course, this class is not there, it will throw an exception. But then what I get here on the left hand side is the reference of the class that will be loaded if at all that class exists. But then otherwise, any class, for example, employee class, dot class will give you the reference of the class. See this. Employee.class will give you the reference of that class, or else employee dot no, sorry. So this will give you the reference, or else the other way to get the reference is employee E is equal to new employee. Okay, I do that, and then I say E dot get class. You can see this E dot get class. This will also give me the reference of the class of employee. In both the cases, what am I getting? I am getting, if you already have an object and you want to get the reference of the class, this is how you do it. Did we define this get class method in the employee class? No. But this, see, there is no get class method here at all. But then every class extends from what? Tell me. Object. And it is the object class. It is the object class in which you find the get class method. You can see this extending. क्या हुआ? क्या करवा, टेस्ट करवा लिया? आ गया? हाँ नेगेटिव ना, माशाल्लाह। नेगेटिव ही है ना, हाँ। नहीं तो मुंह पे बांध लो, सब पहन लो। नेगेटिव है ना, पक्का ना? इंशाल्लाह। हाँ, ठीक है, ठीक है, ठीक है, ठीक है। Okay. All right, see object class here, see get class, isn't it? So this is how it is. This is how it is, you know. So I can get, okay, so this is one way of doing it, but that's fine. So I get the reference of the class. I get the reference of the class. Now, once I've got the reference of the class, let me put this here. Okay. Okay. So I get the reference of the class. Once you have the reference, you can do whatever you want as far as introspection is concerned. You can do c dot new instance to create a new object. I'll say object O is equal to, I'll say object O is equal to new instance. Of course, now I will have to keep on surround this in exception and, you know, multiple exceptions in order to, you know, save ourselves from the edo of all of these exception handling and stuff. I'll say throws throwable, the supermost, right? So it will not complain about anything. So you see this object O new instance. Now this will create a new instance of the class, whichever class this reference points to. In this case, it points to employee. So no, needless to say, it will create a new object of class employee. Now one would say, Shakir, why are you doing this circus? Why don't you say employee directly? E is equal to new employee, right? Okay, so there are use cases for reflection. If we get into those use cases, it will take an hour or two for me to explain. So don't worry about it. There are use cases, trust me. Okay, there are use cases. Why would you do this? And it will become crystal clear to you once you start using your. We are supposed to use. We are supposed to, you know, do training on one topic called ORM, Object Relational Mapping Tool. There it will be crystal clear. So don't worry about that. Okay. So employee E is equal to new employee. I can very well do that. But if suppose you do not have, you cannot anticipate which class you will be using. Here I am anyways referring to the class explicitly, but if suppose I might have loaded this class dynamically, right? From some properties file I pick up the name of the class and dynamically loaded, then in that case of course I would not be knowing the name of the class at the time of compilation, at the time of writing my code, and hence this would work. I mean this would be needed. So object O is equal to new c dot new instance, cool, a new object is created, right? I can say c dot get declared methods, I get the methods. I say get declared fields. Okay, get declared fields. You see, I get the list of declared fields. I say get declared field, just one single field. I get one particular field, right? And I can invoke the method. Like for example, if I say get declared, you know, suppose I want to get declared methods and I get one of the methods. So I'll say I'll get an array of methods. We did discuss this yesterday. I think the day before yesterday or yesterday. Okay, and then one of those methods that I want to invoke, you know, I want to say dot, I can say invoke on which object, on object O. What are the parameters you want to pass? If suppose it takes some parameters, then I need to specify the value of those parameters. Sorry, it must be object, right? I can pass value of the parameters here, whatever the parameters of that functions are. I can very well pass it. Not only that, once I have a method, I can very well get the modifier of that method. You can see that get, you can see this whether it is annotated or not. If it is annotated, what is the annotation? I can get the name of it. What is the return type of annotation? What are all the declared annotations? Maybe there are multiple annotations. Okay, get the declaring class. In which class it is declared? Is it the superclass or the subclass itself? What is the default value and so on? See, get generic types. Maybe there are generic types in the signature of the method. There are so many get modifiers, whether it is public, private, or protected. I repeat, whether it is public, private, or protected. And then get parameters annotation. Again, the parameters can be annotated, right? So that all of this information can be get type of parameters. You know, if there are typed parameters like generic type parameters, you can get them as well. Annotations and so on. So you can get literally everything with respect to the method. In short, whenever a method is declared, it has a signature. It has a signature, right? See this, it has a signature. You see this? It has a signature. This takes no arguments and returns a void. It is a this is the signature. This is the method which takes one argument of type int and it has a signature, it returns nothing. This is a method that takes no argument but it returns a value. All of this is the signature of the method, whether it is public, private, protected, everything. All of that information can be obtained here through reflection runtime dynamically. Right? That's what you can do. So it is pretty interesting and pretty powerful. Given a class, I can also get the constructors. I can say get declared constructors. You can see this. Why? Why constructors? Because there can be many overloaded constructors, isn't it? There can be many constructors that are overloaded. Right? So you can discover fields, you can discover methods, you can retrieve and parse feed modifiers, type information, arrays, and enable creating new class instances. Yes, you can do that. Getting and setting the fields and stuff and all. Yes, you can do that. Retrieving. So if I want to, suppose, can I get the declared field? Yes. So how do I get the fields? Declared field. It's an array. And I say fields is equal to, I can say c dot get declared fields. And I get the list of all the fields. And suppose on one of the fields, this is a rapid thing, friends. Just be, just make note that these are the things that exist. Not at all necessary that, because whenever you really need it, and when you come back to this, that something like this exists. So when you come back to this, you will be able to recollect it. And so suppose one particular field, I can get the value using get on the particular object. The object is O. I will be able to get the value. If I want to set the value, I can set the value. I can set the value. I can say dot set. And on which object? Oh, what is the value that I want to set? Whatever the value it is. I can set. I can of course give an object over here. It can be any object. It can be string, integer, whatever, depending on the type of that field. You got that? That's how it is. So you see, you can do anything. I mean, once you do it, once you have the reference of the class, you can do the introspection. You can invoke the methods. You can get the constructors. You can find a particular constructor by giving exactly the parameters of the constructor. And even if it's an array, then you will get an array as well. How do you refer to an array class? See this. Dot class. See, this refers to the class C is equal to, C is already there, right? So even arrays are actually, objects. You know that very well. Arrays are also objects in Java. So that's how you refer to it. Okay. Fine. So I'll just take a pause of a few minutes. Let me check. There are some questions there, object class and stuff, right? So let me I have already, yeah, correct. That's fine. So I'm not taking a pause here. I will proceed further. I'll just take a pause of a few seconds. Till the time I sip this. If you have any questions, tell me. Okay. All right, so you have a question, sir. If we can get information of class members which are private through reflection, doesn't it violate the security of our application? See, when it comes to this security, the security that you are referring to, I repeat, when it comes to the security that you are referring to, it is not the security, it's not that you are trying to secure the data from the end user. End user is anyways using a user interface. He doesn't even know whether backend, in the backend it's Java or .NET or PHP or whatever. So it is not that security. So what security is this? This is the security from the programmer. You unintentionally do not end up changing the value of a particular variable directly, right? You do not end up changing the value of a variable directly unintentionally. You don't want to make that variable global. You want to encapsulate that variable, the state of the object, and you want to provide setter methods. So the properties that you have defined that are private is to secure those properties from unintentional corruption by the programmer, him or herself, so that whenever you want to change the state of that object, you better go through the setter methods. And setter methods are not just simply the assignments, but maybe 2 3 lines of code which has got some specific logic, maybe some validation done. Suppose you set the value of id. Can it be negative? Can the id of an employee be negative? No, right? See, employee of the id, can that be negative? So there is set id over here. So I check if id is less than 0, or rather less than 1. It cannot be even 0. I say throw new runtime exception. I say id must be greater than 0. Okay, this is what. See the validation that I've written, and this is very meaningful validation. Yes or no? Come on, this makes sense or not? Tell me. This makes sense, or this validation makes sense? Okay. Now just imagine you make this as public. You make this as public. ID is public. Now, unintentionally, from somewhere in the application, since id is accessible, you directly assign a value, and that value happens to be a negative value. Will it go through the validation? Or direct assignment will happen? Correct. So these kind of errors used to happen in procedural approach of programming. In object oriented approach, we have a choice of encapsulating the state. In procedural approach, we did not have a choice of public, private, protected kind of thing. So everything was global, everything was public. So we used to have so much of issues. I, as a programmer writing some code, I know that there is a logic that needs to be followed while setting the value of some variable. But then, somewhere 6 months down the line, people, my stakeholder asked me to make a change. My manager says, Shakir, go ahead and make a change. And I make a change. Oh, well, I want to assign a value. I'll assign a value without going through the method which assigns the value. In such a case, what happens? Directly the value is assigned, and maybe that value is not in line with the validation, right? So now you understand what kind of security. Who had asked that question? Yeah. You understand what kind of security, Rakesh? So this is how you want to secure your data variables from corruption from your own programmers. And when you write a big application, it's not one person. There are many people, working. There are many members in the team for the same application. And if I declare something public, it's quite possible that class, while you using that class, you are my member in the team. You are one of my members in the team. You may end up assigning the value directly. So you understand what kind of security. Got it? And if through reflection, you are one of my members and you intentionally, this cannot be unintentional. You intentionally use reflection and say, and you assign the value to the private variable, then no problem. You be ready with your papers. I will, if I'm your manager, I will ask you to submit your papers if you're intentionally doing it. Kidding, my dear friend, kidding. I hope you're getting what I'm trying to convey to you. Right, isn't it? Yeah, okay. But okay, so since in the interest of making sure that everyone is on the same page. See friends, what Rakesh asked for is that you can assign values to private variables from using reflection. Yes, you can do that. Yes, you can do that. How? When you get the field, say for example, you see this, you get the field, and I try to get the value of it. If it is private, I will get an exception. But if I say fields 0, I'll say dot set accessible to true. Now it will not give an error, and it will get me the value of the private variable out of the class. Employee is a class. It has got a variable, private variable. And if it has some value, I will be able to get that value just by saying set accessible to true. Now, Rakesh, you're there with me? Rakesh, you had asked that question, isn't it? Rakesh. Now see this. Out of 1,000 Java programmers, one will be able to tell you you can prevent this also by installing the security manager as soon as your application starts. There is a concept of system.set security manager, and you can set up a policy. There is a file that you need to create. The extension of that file will be .policy, and in that policy file you can define that private variable set accessible will not be allowed, and in that case when you are shipping your library to a third party, when they use your library in which you have set the security manager, my dear friend, even no one will be able to use reflection to change the values. Okay, now I don't want to go ahead and explain how to use that security manager and how do you set it up and all. That's a process to be done. I mean, it will take some half an hour for me to explain, but remember this: you can prevent it still. You can still prevent it. All praises be to God the Almighty. Okay, coming back over here. So we have talked about, so there are different types, you can have enumerated types as well, examining mediums and all. You can all do that through reflection, that's fine. Okay, IO operations. IO operations is, what is IO operations? How many of you all know about IO operations in Java? How to read a file, how to write to a file, simple stuff. Okay, now don't worry, I will explain few things to you here. So I will take you through some classes. You see there is a class called file reader. You can use this class. Okay, file reader, not from the other packages but from java.io, right? We are learning core Java, and you can see this. You can always create a new file reader. You see this public file reader, that means it's a public constructor, and you can give the name of the file and the file is available to you, and then you can start reading the file using the method, right? File reader. Oh, yeah, so it extends from input stream reader. So this is where you're going to get, you can see this read. You will be able to read into an array. You will be able to read character by character, and also you will be able to read it into an array of character in one shot. You can very well do that. Okay, so you can very well use a file reader in order to read the files. How do you write to files? You can use file writer. You can see that you will be able to use, so that extends from output stream writer, and there here you have functions which helps you to write. Can you see this? Wow, it's raining here. This is the first rain of the season. Give me 5 seconds, please. Awesome. अस्सलाम वालेकुम शबीर भाई, अभी आप स्विफ्ट रखो अपने पास, बारिश शुरू हो गई है, राइट? अभी बाइक मत यूज करना, स्विफ्ट रखो, लेके जाओ. Sorry. Okay, so file handling, yes, so right. Okay, there are many other classes as well. It is very rich. You also have something called, right, file input stream. You can see this file input stream. This also can be used in order to read a file, correct? And any char set, it will help you to read the file. And you see this here, you have functions like read. Again, you can read into a byte array. You can read it into a byte array from one position to the other position. You can keep on reading one by one byte. You can read that. You can read bytes into, there are other methods also available here. You can do that. You can use any one of these methods in order to read, correct? So that's how it is. And then this extends from the input stream, right? This is the class which is there, and here also you've got the read methods, and you can read, and then over and above that, the file input stream helps you. Okay, then similarly you have got file output stream. So in order to write, what is it that you will be using? File output stream. This is what it extends from output stream. This will help you to write to a file. Okay, this will help you to write to a file. And there is one thing that I'm going to share with you now. There is one thing that I'm going to share with you now. Please make note of it. Please make note of it. Please make note of it. From 1.7 onwards. From which version? Type it out. Type it out. From 1.7 onwards. Yes, they introduced something called files. What did they introduce? Files, right? A class called files. See this java.nio.files. And see, since 1.7, NIO library was introduced in which version? I did mention this. I have made a mention of this. No, 1.4. Java.nio, yes, was. So one of the classes of Java.nio is byte buffer. Byte buffer. You see, this was introduced in 1.4. You can see that 1.4. It's raining cats and dogs. Wow. Okay. But files was introduced in NIO. NIO library was introduced in 1.4, but files was introduced in 1.7. This is the class. This is a helper class. Now it is very rich. Why is it that I want to bring this to your notice? That's simple. And I mean, Pappu. What do you mean by Pappu? Don't type some name over here. Huh? Pappu means simple. Yes, yes, Alan. Correct. It means it's simple. It's very simple. You see this copy, 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 copy. You want to copy one file to the other. There are various different copy overloaded methods here. You may want to copy, you have input stream and you want to copy. You have got input stream and you want to specify the path and you want to copy. You've got a copy, you've got a copy method with just the path and then the output stream. Various different, you may have at any given point in time, you may have various different types of file handlers and be using which you want to copy. You want to create a directory, one line of code, create directory, create link. You can create a symbolic link. Then you can you can use create symbolic link also. You can create sim link also, and you can create a temporary directory. You can create a temporary file in a temporary directory. This is very helpful, huh? Because the temp folder on my machine on Mac is different than the temp folder on your machine in Windows, right? What kind of machines you all have in your office? I mean, your office machine, your company given machines, they are Mac or Windows? Okay. So you will have a different temporary folder over there. And on Linux machine, the temporary folder is different. So you don't need to worry about it, which will be the folder and what is the platform that you're using. You just say create temp directory and it will create a temp directory perfectly well in the temporary folder. So temporary directory, temporary file and stuff. You want to delete a file. You want to delete a file. If it exists only, then delete it. You want to find whether a particular file on the path exists or not. See how rich this is. Hello, friends. You can walk file tree. Wow, ये मैंने एक project में use किया था many में some 3-4 years back. It was so very helpful. Walk. You know what? Given a folder, it will help me to walk through the entire tree. It will help me to walk through the entire tree. That means folder within a folder within a folder, entire recursion. It works like this. Oh, tree is not installed on my machine. Hey, come on, jaldi. Chalo, theek hai. When it gets installed, I'll show you. Tree is like, it will give you from the current folder onwards, it gives you the complete tree, the entire hierarchy. Okay, that's what it gives you. So, oh, it's updating the home brew. Anyway, so this is very powerful. It will help you to from where to start, and it will give you the entire structure of the tree. So you can create your own user interface. You can create your own user interface to show the entire folder structure. So this is very powerful, my dear friends. It helps you to read all lines, read all bytes. It helps you to read. Wow, this is brilliant. Read all lines here. Come on, one line of code and you get the list of string, and you can get all the data from the file if it is ASCII data. How powerful is this? Come on, friends. What is the name of the component that I have shared with you? Come on, come on, come on. And with your kind of brilliance, I've seen y'all. I mean, I'm working with y'all since 3 days. I'm not flattering y'all. With your kind of brilliance, though I have not demonstrated the working of it. Sorry. Okay. So though I have not demonstrated the actual working of it, I'm sure with your kind of brilliance, whenever you need it, you will be able to explore this in 10 minutes, 15 minutes, and get started with it. Say yes. All of y'all, please reply yes or no. Say yes. Okay. Good, good, good. Thank you, thank you, thank you. Okay. Now I'm sure you will be able to do it, right? So coming back here, console IO operations, you also have something like, system, system class. You've got a system class, and here you have something like in, right? System.in. See here, system.in, and dot. This is what, an input stream. So you will be able to read it. And then you also had something called console. Now this was also introduced later. It was not there. See, console java.io from 1.6 onwards. It was not there in even 1.5. They introduced this in 1.6. Here console is your console. On the console you get, when you say system.out.println, where do you get the data? On the console. So from that same console, you will be able to read a line from the console. You will be able to read, you can get a reader, and then you can read character by character, and so on. A read line, boolean, it will result into a char array. So you can use console dot, and you can very well read, okay, from the console. Okay. I have talked about not currency, sorry, concurrency. I have talked about concurrency models. What is concurrency? Making two threads run exactly at the same point of time is concurrency. There is yet another term used called parallelism. So what are the two terms that I have used, friends? Please type it out. Now this is something we must really talk about, because these are, see, I ran really very fast on IO. Why? I don't have to explain to you what IO means. You read it from a file, that's input. You write to a file and that's output. Come on, that's no brainer. So with respect to IO, there is no big deal as such. It's just that you need to know the classes, and you need to know the functions of those classes, and you will be up and running. Right? You will be up and running. But in case of concurrency parallelism, it's not only about the classes that you use, but it's about the concepts as well. So concurrency and parallelism, what is the difference between the two? The difference is there. Both use threads. First of all, make note. Concurrency and parallelism. They both use they both use threads. Concurrency is for better user experience, where in one task is being done in one thread, whereas another task is being done in another thread. One task that is being done in one thread is agnostic and least concerned about the task that is being done in the other thread. That is concurrency. But if you have one big task to execute, I repeat, if you have one big task to execute, for example, you want to sort a collection of 10 million elements. You want to sort a collection of 10 million elements. You can imagine the time that it would take if you say collections.sort. So why? Because that is single threaded. But you want to now implement an algorithm, not my words. You want to implement an algorithm such that your algorithm will distribute the sorting Of that one single collection, it will divide the collection of 10 million into four halves: 2.5 million, 2.5 million, 2.5 million, and 2.5 million. And you will assign each one of those buckets to one thread, another bucket to another thread, third to third, and the fourth to fourth thread. So you break down a collection of 10 million elements into four elements, because you have got four cores on your machine, and you assign each bucket, sorting of each bucket to a particular thread. So how many threads will be running in parallel to do the job? Four threads. One thread on one core, second thread on another core, third thread on third core, fourth thread on four core. So four threads will be running compute intensive, tasks are performed in all the four threads in parallel, so that finally then you can merge the results of all the four threads, and you get one single final collection which is sorted. So you have one data structure or one big task to perform. Okay, let me put it like this. Suppose I have a gallon of water over here of 20 liters, gallon of water, 20 liters water. I have it over here, 20 liters. And there is an empty gallon at the other end. And you tell me, Shakir, you are supposed to take these 20 liters of water from this gallon and you've got to pour it over there. You've got to put it over there. Of course, I cannot carry that entire 20 liters in one shot. So what I do, I take a bucket of 5 liters and then I fill that bucket here. I walk down and I put it over there at the other end. When you see me doing this, you say, Shakir, wait, why don't you take three more people along with you? So now we are four of us. Each of us, we have got 5 liter bucket in our hand. Now we take the water 5 liter bucket, each one of us. So we go and we pour it at the other end. Tell me, one person doing the job will complete one big task faster in this case, or four people? When the job is divided among four of us will end up doing faster. What do you think? Four of us, right? Four people. This is parallelism. This is parallelism. If any one of us fail, the entire big task will be marked as a failure. So we are four of us. We are participating. We have been given individual tasks, but each one of those tasks put together, we are all participating in completing one big task. And at the end, we have got one final result. We have got 20 liters of water at the other end. This is parallelism. So when you divide one big task into multiple tasks, that's parallelism, right? One big compute intensive task needs to be performed, but then at the end you get one single result and you divide it into multiple threads. That's parallelism, right? But in cases where you just simply need better user experience, one thread does something, so the other thread shouldn't be waiting for one thread to complete, and then only it starts the other job. So in concurrently, I mean concurrently, while one thread is doing something, this thread also does something else. The player example that I had given you, YouTube player, that is concurrency. That is concurrency, right? One thread may have, the one that is the downloaded thread may complete its job, but halfway. But then the player thread will at least, keep playing till the time it has data in the buffer. So concurrency and parallelism. In both the cases, you end up using threads. And now, how do you create threads? We did talk about it, right? Isn't it? How do you create threads? How do you work with threads? How do you create threads? Come on, you know that. We have done this. How do you create threads? You create a thread by, you create a class. I'll say, for example, sorter thread. I'll say extends thread. I can create a class like this, and I can say run method. This is one way of doing it. Now what I do, or say, let me make this as vacation thread. Vacation thread. Okay, and you want to go for a vacation, and you are unable to decide, where should you go. You must go to Dubai, or you must go to UK, London. You must go to Dubai or London. So you write a program. See, I'm giving you a very simple example out here. You write a program. And the program that you write is somewhat like this. You say vacation thread, and there is a constructor here. You say public, and then you take the name of destination, right? Destination. And then here you say private string destination. And you say what? This dot, I don't think I need to explain this in detail. This should be easy, right? Destination. And then here in the run method, you say while true, okay? Or else you say, let me use a normal for loop for int I is equal to 0 until I is less than 10, I plus plus, okay? And I will use a random r is equal to new random, okay? And then this random is is from java.util library. Random helps you to generate a random number. So what I'm going to do here is that I'll say r dot get int okay, sorry, get r dot get, sorry, next, so sorry, next int, and I can give seed the bound. I can give bound, not the seed, sorry, I can give the bound 1000. What does this mean? It will return to me any random value lesser than 1000. I repeat, it will return to me any value lesser than 1000, any randomly any value. So I keep that into a variable long sleep time, okay? And then here I write thread dot sleep, whichever the current thread is dot sleep, I'll say sleep time, okay, in millis. And of course I need to surround this in a try catch block. And then here I print system dot println I am going to, okay, I am going to, I'll write this dot destination. See the code, very simple. I don't think I need to explain this, right? It's very simple. It's a simple code. So now what I do is I'll say in public static void main, I say vacation thread t1 is equal to new vacation thread, right? And I say Dubai, correct? And then I have another vacation thread, but this time I say London, correct? I say London. Now I'll come to runnable. First, see this. I'll come to runnable, my dear. Okay. So see this now. First of all, see this. So tell me, how do I start a thread? Do I need to say run or I'll say start? Come on. T1 dot what? Yes, correct. So I'll start a thread, T2 dot start a thread. Now this will tell me finally where I'm going. Why? Because both of the threads will run concurrently. I repeat, both of the threads will run concurrently. Both of these threads will be in, both of them will be running concurrently. They will start together, but then, what will happen is in this thread, perhaps one first you go in the loop, it sleeps for 500 milliseconds, maybe 200 milliseconds, maybe 340, maybe 350 milliseconds. So both the threads will be running in parallel. Now, just for the sake of your understanding, I'll say reported by which thread? How do I get the name of the thread, friends? Thread dot current thread dot get name. Correct? Now let me run this. So this is how the threads work. See this? So 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. You can see this. But then where am I going? Okay, finally I'm going to London. Right? It can be anything. Each time you run, it can be anything. Right? So Dubai, London, Dubai, London. It depends on how much time, randomly, what for what amount of time. Okay, this time I'm going to London. Acha, last time also I was going to London, right? So it can be anything like, Dubai, London, Dubai, London, whatever. So this is how threads work, both the threads are running in parallel. So one of the threads is thread one, whereas the other thread is thread zero. Okay, so two threads are running concurrently at one point in time. Now, there is something called runnable as well. So this thread, what is it? Is it a class or an interface? Is it a class or an interface? It is a class, right? It's an interface. It's a class, right, Rakesh? What is it? It's a class or an interface? अरे राकेश ये क्या है? ये thread is a class or an interface? It's right here in front of you. Correct? Yeah. It's a class. It's a class. And it implements runnable. I'll come to the runnable part. But it's a class. Thread is a class. So if you have a class to create, which is a thread class, then you need to extend it from thread. Now, what is a runnable? What is a runnable? Now, you know what? Again, people with good amount of experience, if I ask them, what is a runnable class? What is runnable? What is runnable? This is what they say. It's an interface. One is a class, the other is an interface. Oh my God, I know that it's an interface. That's not the point. I mean, if this is the answer that I got, then I understand. If this is the answer that I get, then I understand. I mean, that means you have not worked on threads. You have not worked on multi-threading. Runnable, yes, it's an interface. I mean, don't even tell me. Yes, I know it's an interface. But runnable represents a task that will be executed in some thread. I repeat, runnable is a task that will be executed. See this. Now, when I say runnable, it's a contract. It's a contract, public abstract void run. It's a contract. Any class implementing runnable will provide the implementation of run. That's it. That's it. There is no meaning to this, any meaning to this other than this. I repeat, it is not a thread. It is not, it has got, I mean, people are so confused. This is just an interface as good as any other. Okay, forget about it. So it is a functional interface because it has got only just one method, and I can write it as a lambda expression. Forget about that because it is there since 1.0, right? 1.0 में तो functional interface नहीं था ना. So forget about that for the time being now. It's just that now it happens to be functional interface because there is only one abstract function in it, and I can write a lambda expression to provide the implementation of runnable. छोड़ो उसको, leave it. Runnable is used to execute code on. You're right, Bhartiya. Very correct. Very nice, Bhartiya. Very good. That's the point. So runnable represents a task. 1000 बार बोलो अपने आप को. Tell this 1000 times to yourself. Runnable represents a task that will be executed in some or the other thread. It will be executed in some thread. It's a task. It is the runnable and the name of the function is run. It could have been bhagable and the name of the function could have been bhag. Okay, fine. Correct. So it's just that it's an interface and it represents a task. Now, what does that mean? What does that mean? If I create a runnable, if I create an object of type runnable, I cannot run it in some, I can run it in a thread. I can execute it in a thread, but I can execute it in a thread, that's fine, but it is the thread class that will be executing it. So for example, I can now say, so since it is a, I'll say runnable R is equal to, I can say new runnable, something like this. Why not? This is an example of what? Come on. This is an example of what? Object of an, come on, one word answer. Object of an, jaldi bolo. Yes, object of an anonymous inner class. Very good, Rakesh. Object of an anonymous inner class, and that's what I'm doing over here. But since you have picked up that point that it is a functional interface, I can very well write something like this as well, right? Instead of runnable R is equal to anonymous, I mean object of anonymous class, I can say R is equal to, can't I write this? I can write this also. Come on, I can do this. I'll write system.out.println in thread. You see this? I'll say plus thread dot current thread dot get name. Correct? Now, if I execute this r dot run, I will be the happiest person. Don't haste. Don't haste. Give me the right answer. Okay. If I say r dot run, what will be the name of the thread printed? आराम से सोच के बोलना. Okay, think and then tell me. What will be the name of the thread printed? Tell me. No? Tell me. Rakesh says main. Anandya says T2. Gaurav says main. Acha, those who are saying T1 and T2, how come? How come T1 and how come T2? When T1 dot start happens, this will be executed. The run method of this thread will be executed. T1 is this thread, vacation thread. T2 is this thread, right? T2 is again an object of vacation thread. So it is this run method that will execute, isn't it? How come T1 and T2? Now you know what is this? This is nothing more than a object of some anonymous class that implements runnable, and you are just simply executing it in the current thread itself. It will print main only, my dear friends. Please check this. It's going to execute, and because you are just simply executing that function directly, right? You see, I in thread main. Can you see this? I mean, just simple stuff, right? Why? Because I'm not executing in a thread. So what is a task? So if I wanted to execute this in a task, I'll say thread. Okay, see this, see what I'm doing. I'll say thread. T3 is equal to, now see what I'm doing, new thread. And in that I'm passing in the constructor. I'm passing that R, that is a runnable, as a parameter. Now when I say T3 dot, okay, T3 is what? A thread. How do I start it? How do I execute the thread? Come on. T3 dot, T3 dot, come on. Start. And when I do that, now tell me what will this print? Which thread will it print? T3. Yes, that runnable will execute as a task in runnable will execute in the task will running runnable will execute as a task in thread T3. This is what threads are. This is what runnable is. Okay, this is exactly what runnable is. Now see, take a look. Okay, thread 2. Can you see this thread? Why? Why? Because it starts naming the thread from 0. Thread 0, thread 1, and then I created the third thread here. So it's thread 2, and so on. Isn't it? Getting the point? I hope the difference is clear. Runnable is nothing, but it's just that it represents a task. Got that? That's how it is. Now it's getting more interesting, friends. Now I'm going to take you through that to the next step. Uh, Creating of a thread. Take a look. What do you think the moment I say a new thread is created and the moment I start it, especially when I create a new thread, it is in the new state, it is not runnable. But the moment I say dot start, now the thread swings in action. All with me, friends? Please confirm you are all there with me. All there? Good. Good. So please listen to this. Okay, by the way, I talked about parallelism and I said you must divide the task into the total number of cores. So, how do you know on which machine when your program runs? How will you know which machine has got how many cores? Can you find that out? Is there a way to find that out? Is there a way to find that out? No, I'm not starting T1 and T2, huh? I'm not starting that. I'm just running this. How to find out? Tell me. I'll tell you. See this. System.out.println runtime dot get runtime dot available processors. What will this give you? The total number of cores, or rather the total number of threads that can be executed at one point of time on your machine. Okay, on my machine this will nazar nahi lagana, huh? 16 threads can execute. It's not a 16 core machine, but it is a 8 core machine. Nazar nahi lagana. I'm just kidding. Just kidding, guys. Well, this is a high-end machine, yes, and it's fun working on this machine. See, total number of cores is what? 8. There are 8 core, but then 16 threads can execute. Why? Because on this hardware, hyper-threading is enabled. And when you have, yes, yes. So when you have hyper-threading enabled, each core, the resources of each core is divided such that two threads can execute exactly at the same point of time on one single core. Hence, it reports 16. Got it? Hence, it reports 16. Right. So the machine keeps on becoming more and more expensive, not only based on the number of cores that you've got, but also the cache unit. You see, there is yet another thing over here called cache unit. You can see it has 16 MB of cache. You can see the 16 MB of L3 cache and 256 KB of L2 cache. Apple has machines with 24 MB of cache as well. And this is the cache memory cache unit, which is there on the processor itself. It is etched onto the processor. Anyway, thoda beyond scope ho jayega. So this is how it is. You can find it out. Okay, now coming back over here. So we were talking about something. Now what that something is, please see. So we did talk about the concept of creating the threads. Okay, we talked about that. Take a look at the threads here. If I have multiple threads, each thread is executed in its own stack. Yes or no? Point one. Each thread executes in its own stack. Correct? Your JVM maintains the interrupts and signals across each one of the stacks. It pushes the functions and it pops out those functions. It maintains the references of the objects from stack into the Java heap. Each thread has got its own execution context. It needs to give the execution to the runtime environment, talks to the operating system saying that this is a different execution context, this is a different thread. You better use a different thread to execute on one of the cores. In short, creating a thread and managing it, and especially creating a thread and managing it, right, is expensive. It is a compute intensive job. I'll repeat once again. Creating a new thread every point in time, creating new threads is a compute intensive task and memory intensive task. So if you want to support thousands of concurrent executions, if you want to support thousands of concurrent executions, it is not advisable that every now and then, whenever you want to execute something in a different execution context, all in itself, in a different thread, it is not advisable that you keep on creating new threads every now and then. What is advisable is you create a pool of threads. You create a pool of threads. You create a pool of threads. You create thread pools. Okay, you create what? You create thread pools. And when you create thread pools, when you create thread pools, you create some specific number of threads and keep them ready. You create tasks, new tasks, and keep on assigning to the thread pool. Thread pool will take that task and execute it in one of the threads that is free. I'm saying that is free. While that thread is busy, it will take another task and give it to the thread that is next free. Maybe you create a thread pool of 10 threads. It will take the task and give the task to one of the threads that is free, and the other task and the other task. Suppose all the 10 threads are now busy. Suppose. And then you give the 11th task also. It will keep it in the queue. I repeat, it will keep it in the queue. And the moment any one of these threads become free, it will take that task which was in the queue and give it to one of these threads so that that task also gets executed. And if at all the task comes, and while and the moment that task, the new task comes, if the thread is already available, if one of the threads is free, it will immediately assign that task to that free thread and the thread will execute. So what you end up doing here is that instead of instead of introducing the overhead of creating the threads every now and then, which is a compute intensive job, Managing the threads and maintaining the threads, large number of threads will result into heavy context switching as well. Well, I don't want to go that route. What is context switching? Leave it. But then many threads on your machine will make your machine slower. So instead, what you do is that you have fewer number of threads, maybe 100, 200 threads. So still you have 4 cores, maybe 8 cores, maybe 16 cores on your machine, maybe 32 cores, but you can still have 200, 300 threads created. It will be there in the queue and it will be there in the run queue. Time slicing will be done by your operating system. It will assign the thread, it will allocate the time to the to each one of the threads. So those threads will be like, kind of, not kind of, actually it's a multitasking. So this thread gets a chance, it works, and then goes back in the run queue. The other thread comes in, it gets a chance to work on the core, and then it goes back and so on. But you as an end user, you get a feeling that everything is working. Everything is working, right? So there is a concept of thread pool. I repeat, there is a concept of thread pool. Now, let me check that, right? So how do you create thread pools? That's the point then. How do you create thread pools? Okay. So I will keep this as it is. Okay, I'll create a new class and I'll say thread pool executor. Uh-oh, you must never ever name your classes as same as the class name given by Java. It's not advisable. Not that you cannot, but it's not advisable. I'll say demo. Okay. Here I give the function as the main function. Okay. And see this. So I want to create a thread pool. How will I create it? I'll say executor service. Again, this was introduced from 1.5 onwards. See, 1.5. Correct? This Doug Lee is the master, you know, major, all the major components. I mean, how to put it in English? I'm sorry, I'm falling short of words. I mean, major components, and I mean, almost 95% of the components, more than that is written by Doug Lee. Which components? The concurrency components. Java.util.concurrent library. There are n number of things that are written by Doug Lee. He's a master guy. Okay, so coming back over here, executor service is equal to, then there is a factory method, an abstract factory class, executors dot, again, sorry, executors, okay, dot, and I will say new cached thread pool. You can see that, new cached thread pool, correct? So this gives me a thread pool. Now, what is the behavior of this thread pool? It will keep on increasing the thread pool size. It will keep on adding new threads as needed, and it will keep the thread alive for 60 seconds. If there is no new task submitted in the queue, it will remove that thread. Otherwise, you can also work with something like this. We'll say new fixed thread pool, and I can say 10. How many threads will be created in the pool? 10 threads. How do you submit the task? You say service dot, I'll say execute. What will I do? Service dot execute. And when I say service dot execute, what is it that I need to provide as a parameter? Take a look at my IDE. It is giving me the hint. You tell me. Tell me. Yes, runnable. So I'll say new runnable. Okay, this is what it is. I'll say new runnable. And when I say new runnable, I can just simply give the task over here. I'll say s out. I'll say this task is executing in which thread. I can very well specify thread dot current thread dot get name. Right now, when I execute this, please see, it will execute this task in one of the threads of the thread pool, and internally the thread pool is created and it names the thread as pool 1 thread 1. So I can keep on submitting the task. If I submit more than 10 tasks, it will keep those tasks in the queue. right? This is how it is. What's the time? Okay, very good. We will take lunch break at 1:30. Okay, we will take a lunch break at 1:30. Okay, so okay. So now if suppose you have to execute the task, right? If you want to execute, so this is one kind of an executor. I repeat, this is one kind of an executor service which helps you to create, a thread pool and submit the tasks to that thread pool. What if you want to schedule a task to execute at a later stage? What if you want to execute a task at a later stage and also maybe you want to repeat it periodically? You want to keep on repeating the task after some specific interval. And those tasks that come in should also execute in one of the threads in the thread pool, but periodically. How will you do that? You will do that like this. You will say executor, scheduled executor service. So I'll say scheduled executor service is equal to, I'll say scheduled executor. Executors dot new single threaded or new scheduled thread pool. Can you see this? And you can specify new scheduled thread pool. And I can very well specify here the size. I say 10, for example. Okay, I can say 10 or whatever number I want. Right? It depends on how many threads I want in the thread pool. And then what I do is I say schedule. Now see this, see the service here. I can say schedule. I can schedule a task to execute. Brilliant stuff. I can schedule a task to execute. What is that task? I say new runnable again. Tell me one thing, runnable is what kind of an interface? Come on, you'll all know now. Runnable is what type of an interface? It's a functional interface, yes or no? Runnable is a functional interface. So instead of writing like this, can't I write something like this? Come on, yes or no? Correct? I can write it as a lambda. Perfect. But since it is scheduled interface, you see, what is the second thing? Delay. What do you mean by delay? I'll say 5 dot time unit dot, of course not days, we won't be able to test it. I'll say 5 seconds. See, so I'll say as out, this will execute after 5 seconds. See this, now I'm going to execute it and you see this will execute after 5 seconds because I'm scheduling it to execute after 5 seconds. Take a look. See, so the first task got executed immediately because that was a plain simple executor service, but this gets executed after 5 seconds. Take a look. Okay, I also have to shut down the, okay, I'll come to that later. See this task is executing in pool thread 1, but that second task, it is scheduled, so after 5 seconds this comes up. Why my JVM is still running? Because once the thread pool is created, all the threads in that thread pool are active, so the JVM doesn't close. So what I will do is that we can very well go ahead and terminate it. I can close the pool, so I can say execute a service dot await termination, and then after that I can very well say execute a service dot shutdown. Can you see the shutdown? Okay, anyways, so this is how it is. Now what if I want to keep on executing this? I want to keep on executing this after every interval, so I'll say schedule. You can see this I've got something called at fixed rate as well. So I will now have a chance to specify yet another parameter. I'll say after every 1 second. After every 1 second, let me check the signature. Period time unit, yes. So I will have to give the time unit towards the end. Perfect. So what does this mean? It will start after 5 seconds, but it will keep on repeating after every 1 second. Take a look. So after 5 seconds it starts, but then keep on repeating after every 1 second. Isn't it? Simple stuff, right? Simple stuff. right? This is how. Okay. Executor periodically controlling task finishing in an executor. Yeah. So if you want to control the task that is finishing in an executor, you can always say scheduled executor service or whatever, and you can say await termination. So you can say, let me wait till the time it is not, all the tasks are not completed, and I can very well, give a timeout there. And then you can also say shut down, and you can say shut down now. Don't really wait for all the tasks to complete. Just say shut down now. When you say shut down now, no new tasks will be accepted. That's the point. I don't know what they mean by getting the first result and getting the last result and first result. Okay, so we have covered them all. Okay, we have covered them all. Perfect. Right. So this is how it is. This is how it is. And then there is a concept of timer also. Java.title.timer, which was introduced in Java 1.3, way back in 1.3 timer. And in that timer, you can very well create. I'm just giving an example. Say my timer class extends from timer java.title.timer, and then here I can say, okay, yeah. So there is a run method here that I can. Yes, I can. And then here, whatever code I want to write, I can very well write that code here. And then after I've written the code, I can very well say this dot cancel. You can see that. So I can cancel the task as well. We can very well cancel the task. Okay, so this is one way. But then if I want to cancel the task here also, so what I provide here as a parameter here is a runnable. You can see this runnable command and stuff. But then schedule. No, oh, correct. So that's the only way of doing this over here. Perfect, perfect. Okay. Sorry, I was getting into something else. So separating the launching of tasks and processing of their results in an executor. Yeah, yeah. It's one and the same thing. Okay, now another important stuff. Fork join pool. They introduced this in 1.7, right? 1.7 fork join pool, right? We still have 20 minutes, friends. I hope you all are not exhausted. You all want a break of 5 minutes? Say no. Good. Thank you, Caution. Right. So see, fork join pool. What is a fork join pool? They introduced fork join pool in 1.7, Java 1.7 fork join pool. What is that? It's not easy to write algorithms for parallelism. You have, very compute intensive tasks to do, and it's a big task. Maybe sorting, maybe something else. But then it is not a cakewalk to implement this complex algorithms. So what they did is that they provided a feature called fork join pool, a component, a framework called fork join pool in 1.7. See this fork join pool, right? This is 1.7. Now, what does that mean? This means that, and what this is exactly. Okay. So fork join pool, it's pretty simple stuff. You have to, you can create one task, right? And you can keep on breaking down that task and submitting it to the fork join pool. What fork join pool does is that it automatically creates. So I'll say fork join pool is equal to new fork join pool, right? By default, it will create the threads automatically. It will create threads equal to the total number of threads, equal to the total number of cores on your machine minus one, minus one, correct? So if you have 16 cores on your machine, it will create 15 threads, right? And it will keep those threads ready in the pool. And then when you submit the task, what kind of task you will submit? You say fork join pool dot, and you will say execute, and you can specify the task. You can also submit a task called runnable, right? Something like this. Or then you say execute. Execute this method, fork join task, right? And you can execute new either recursive task or recursive action. Suppose you say recursive action. You see this, the compute method here. Now, this is the crux of the matter, compute method. So suppose you have some tasks to be performed, like for example, you have some, a large array list and you want to do the processing on that array list. What you can do here is that you can check the size of the array list and you can check the threshold or maybe some other logic, based on which you will further divide the task, or else you will execute the actual task and perform the action. So for example, here you say, the threshold is whatever the threshold or whatever the condition is. Based on that condition, you will say fork join pool dot invoke. Sorry, fork join pool. Sorry, fork join task. Right, whatever the task is dot. You see there is an option of invoke. So you can invoke the task over here. So this task will be again submitted to the same fork join pool. In short, it works on a work stealing algorithm. I repeat, it works on a work stealing. Let me give you the conceptual and the theory behind this. That will be easier. Okay. So you have, see, this is, don't forget, friends, this is fast track. So you just need to understand the theory part of it. No problem. Otherwise, beyond this. So you have, you have a task to be executed. You submit that task. So this is your task. This is the first task to start with. And your fork join pool, you submit this task to the fork join pool, right? You have fork join pool object, fork join pool. You have this framework with you, right? You have created a fork join pool. And how many threads are there in that? Suppose if it's a quad core machine and if its hyperthreading is enabled, so you will have 8 threads here. Okay, whatever the number of threads are. Suppose it's a dual core machine, so you have 8 threads. Okay, it will have 8 threads here. It has 8 threads, and you submit the task to this fork join pool. The task is submitted. Correct. When you submit the task, it will take the task and execute it in one of the threads, right? But first of all, before putting it in any one of those threads, what it does is that it creates a queue as well. It creates a queue per thread. For each one of those threads, there is a queue. So there is a thread, there is a queue here for this thread. There is a queue here for this thread. There is a queue here for this thread, and there is a queue here for this thread as well. Okay, so these are the queues. These are the queues, whereas these are the threads. These are the threads. And when you submit a task, right, you have a task to be submitted. So when you submit a task, that task goes into the queue of one of the threads. You submit another task, it goes to the other thread. You submit another task, it goes to the other thread. You submit the task, it goes to another thread. You still keep on submitting the task. So when the moment it is submitted to the, the task is submitted to the thread, to the queue of one of the threads, of course, the thread is going to pick up that task and start executing it. Suppose all the 4 threads are busy executing the task and you keep on still submitting the task, those tasks will get lined up over here in this queue. And very importantly, it works on work stealing algorithm. Work, please repeat what it is. Work stealing algorithm. I have the habit of saying algorithm, algorithm. This has a history behind it. I was in UK for one of my projects, and at JLR, you might have heard of Jaguar Land Rover, right? Yes. So, the people that I was working with, they were British people, and I told them algorithm. We were talking about something in algorithm. They said, "What?" I said, "Algorithm." They said, "What?" I said, "Algorithm." They said, "What? Sorry, what are you trying to say?" So one of the ladies, he said, "Oh, he's trying to say algorithm." I distinctly remember 4 or 5 times I told them, and I was, kind of looking like a idiot there, that I don't know how to pronounce, and it's a very different way in which they pronounce that algorithm. He's trying to say algorithm. That's how. So that's the reason. So since then, while talking to our Indians also, I say algorithm. Okay. So yeah, that's how it is. So work stealing algorithm. So what that algorithm is, so it keeps on pushing the tasks to the queues. Now what it does is, if at all it sees, the moment you keep on submitting the tasks, right? You keep on submitting the tasks, and the queues receive the task. Now, if any one of the, now this is the framework, right? This is how the framework works. It keeps on monitoring. If it sees that this particular thread has got fewer tasks to execute, it will steal the tasks from the queue of the thread which has got many tasks. So if suppose there are, say, 10 tasks lined up here, but if this thread is fast enough to complete its job and there are only 2 tasks available over here, assuming that these are also the threads that has got its own queue, and of course not assuming that it will definitely have its own queue, and these queues assume that these queues also have got considerable amount of tasks to execute, but then this thread is now having a queue with just 2 tasks. It will steal the task from any one of these threads. So suppose this is the thread which has got some more tasks, it will steal the tasks from here, and say for example it steals 3 or 4 tasks, and then it starts executing it. That's the algorithm that it works with, work stealing algorithm. And programmatically, you use either recursive action or recursive task and submit it to the fork join pool. I repeat, you either use recursive task or recursive action. You will have a test. You will have a test. Don't forget about that. You will have a test. There are two types of, you have two different types of tasks that can be submitted. Okay. Recursive action, recursive task. The only difference is, in case of a recursive action, you see this is recursive action, it doesn't return a value back. If it was a recursive task, it can return a value back. You can see this recursive task here. And if I say it's going to return an integer value back, that means you do all the processing, and finally what is returned back is an integer. So you have to return back, say, some value. I mean, of course, I'm hard coding. You will be calculating, computing. See, compute is the function. So you keep on, right? Invoke all, invoke all, invoke all. It's like, you have, see this now. You have one task to start with. Okay. Right. We already have that task here, right? We have one task to start with, but then in the compute method, I repeat, in the compute method once more, you know you have a you will have a test. In the compute method, you decide whether you want to break down the task or just go ahead with the computation. If you go ahead with the computation, well, the buck stops there and that task will be executed in the queue. But otherwise, you may decide, no, I want to break that down into 2 tasks, right? So you've got 2 tasks. Now, this task again, you decide that if it is just good enough to stop over here and further not break it down, cool. Or else you decide to break it down further. You have got these 2 tasks again broken. You have these 2 tasks again broken into 2 tasks. Again, you decide that in this task, should it be further broken down, or it is just good enough to to be computed. Again, you decide, and then it is broken into you know multiple tasks like this. So this is how you go on you go on divide and conquer. You keep on breaking down the task and keep on submitting it to the fork join pool using invoke all method. In the invoke all method, you can very well pass as a parameter. You see this, it takes another fork join. You see this, it takes another fork join task as a parameter. Got it? And it gets submitted to the same pool. It gets submitted to the same pool. Okay, and this is how. So the tasks will get accumulated where? One word answer. The tasks will get lined up in what? The tasks will get lined up in what? Yes, in the queue, right? In the queue. Correct. Right. That's how it is. Okay, perfect. So this is your Fortran pool. You can always throw an exception, not a big deal. You can always cancel a task as well. And based on the condition, you can just come out of it. Cool. Okay. Now see this. So you have, how much time do we have? We have still almost 10 minutes, 17 minutes to be very precise. So the next thing is, yeah, correct. I've already talked about this. I've talked about this. Atomic variables, atomic arrays, keywords, variable handles. Okay, so I'll just give you overview of few of the things over here. I did talk about the. Can you give me? Can you give me the name of some data structure which is thread safe? Okay, vector or an array list. There will be a test. Vector or an array list. Which one of the two is thread safe? Very good. Array list is not. Very good. Okay, very good. I'm so happy with the with the prompt answers. Okay, right. So that's as thread safe, right? Vector is thread safe. Then so there are many such data structures which are thread safe. Or you will always find on the documentation on the top of it whether it's a thread safe data structure or not. Stack also, yes. Stack also, correct. Vector stack, yes. So you can find that out, right? But then they did introduce some data structures. Okay, now collection here. I'll put it over here. Or else let me create a new package. Blocking data structures. This was again introduced in 1.5. I'll say class and I will give the name of the class as blocking queue demo. Pretty simple stuff. You know what? I'll say main function and then I can create blocking queues. What do you mean by blocking queues? Say for example, I create a blocking queue of type say string. I want to put some values. Okay, it's a queue. I can keep on putting the values first in first out. It's a queue. And I'll say bq is equal to new. I'll say array blocking queue because this is the interface and I need to give array blocking queue. And I will say the it's a bounded data structure. Repeat, it's a bounded data structure. I'll say 5, for example. What does this mean? I cannot have more than 5 values. I cannot have more than 5 values. Or let me make it 3. I cannot have more than 3 values in this. So if I try to put more than 3 values, it will block. I repeat, if I try to put more than 3 values, it will block. For example, bq dot, I'll say add, and I'll say v1. This is the value 1. It will be successful. Why? Because the capacity is 3. I say 2 successful, 3 successful. Why? Because the capacity is still, v1, v2, v3, right? But then, if I try to write system.out.println before adding fourth value, if I say now bq dot add the fourth value, say v4, it will not reach here at all. Take a look. It will not reach here at all. See, this task is executing. Oh, sorry. See this? Okay. Now, instead of add, I'll use put. So put will not give me an exception. Okay, I'll do this. Okay, now see this. Instead of using add will give you an exception if you try to put a value in a queue which is already full. See, before added fourth value, before added, no, adding, sorry, wrong English. Before adding the fourth value. So it will block. It will not proceed further at all. See, it's blocking. Before adding fourth value, blocked. It doesn't proceed further. It doesn't reach here at all. I'll say after adding fourth value. Correct? I won't reach here at all. I won't reach after adding fourth value. I'm not reaching here. Why? Because it is blocking here. Because the capacity is full. But then if at all one of the values is removed and if the capacity is there, if there is some space in which, so that you can put the value, it will successfully put and proceed further. So what I'm going to do here is, before I try to put the fourth value, I'll say new thread, I'll say run function, and I say dot start. Any problem in understanding this? Any problem in understanding this? I have created a new thread. I did not assign a variable, and there itself on the object of that anonymous class, I have executed dot start. Kya problem? Simple, isn't it? So here, what am I going to do? I'll say BQ dot, I'll say take. Take will give me the value, and this will give me the first in, first out, right? So I'll say S out, and this will give me right from the head. Again, I'll have to surround this in a try catch block. And when will I do this? I'll say thread dot sleep. So this new thread object that I have created, I will make that sleep for 5 seconds. And I will put this also in this, right? So I will put 5 seconds here. So after 5 seconds, the thread will start immediately, but after 5 seconds, it will take the value. That means it will remove a value. That means now there is some space. So after 5 seconds only, this will be successful. So this will proceed further. So this is blocking. This will block, and it will not allow me to proceed further till the time at least one space is not available. So take a look. Okay, so it says before adding the fourth value, and after 5 seconds it will take the value, and after 5 seconds, the moment it takes the value, you see this, it gets the value, it prints it, and then after adding the fourth value, it proceeds further, it reaches here. You got the point? Blocking queues. You got the point, right? So there can be multiple threads. It's absolutely thread safe. Some thread can put the value, some thread can take the values. This is a typical example of publisher and subscriber, or else you can say producer and consumer. Repeat, producer and consumer. Some threads can produce value in the blocking queue, and some threads can consume the value from the blocking queue without any issues of synchronization and stuff. It takes care of it very beautifully. This is thread safe data structure. I repeat, this is thread safe data structures. Right. Now see, there is a concept of volatile variables, what's the time? Okay, it's 1:30, and this has been already quite overwhelming. So I will, and you all have to go through that e-learning stuff also. But we are coming back in 40 minutes. We are resuming back. Okay, in 40 minutes we are resuming back. So it's 1:30, 2:15. We will be back. Let me push this code. Okay. You can take the poll, take a look at it, but do have your, spend time with your lunch stuff and all, have your lunch, and then we are coming back at 2:15, and then we will spend an hour or so, maybe, up till 3:15 or so, and then you can go ahead with that e-learning stuff. Right, friends? I hope that's fine with every one of you all. Okay. Yeah. Thank you. Thank you.